What is time? And does it really exist? Imagine that you are sitting on the shore of an endless ocean. The wind gently caresses your face. The waves calmly roll onto the shore. Somewhere far away, the sunset bathes the horizon in a golden glow. Time flows here and now, but what is time really? Time, as word, is simple and at the same time immeasurable. We live in it, breathe it, we grow and age under its influence. And yet, if we ask ourselves honestly, what is time? The answer will dissolve like smoke in the wind. In everyday life, we perceive time as a constant movement from the past through the present to the future. But does time really flow, or is it just an illusion? The feeling of time when we are happy, time seems to fly. When we suffer, it stretches endlessly. So the first thing we can notice, time depends on our perception. Our brain measures time not by a clock, but by the number of events experienced. Many impressions, it seems that more time has passed. Few changes, time seems compressed. The scientific definition of time, physicists define time as a quantity that allows us to arrange events in sequence. What happened earlier and what later. In classical Newtonian physics, time was absolute. No matter where you are, time flows the same for everyone. Newton believed that time is an unchanging arena where events are played out. But Albert Einstein changed everything. Einstein's discovery, time is relative. In his special theory of relativity, Einstein proved time depends on the motion of the observer. If you are moving very fast, almost at the speed of light, time flows more slowly for you compared to those who remain stationary. This is not a fantasy, but a proven phenomenon that we observe even in GPS satellites. If we did not take into account the relativity of time, they would quickly fail. Is there a now? From the point of view of physics, there is no absolute now. For you and for someone on another planet, now can mean different moments. In one place, an event has already happened. In another, not yet. Time and space merge into something larger. The space-time continuum. Philosophical reflections on time. Philosophers have puzzled over the question of time for millennia. St. Augustine wrote, "What is time? If I am not asked, I know, but if I am asked, I cannot answer." Some believe that time is just our way of ordering experience. Others believe that time exists objectively, independently of us. And there are those who believe time is an illusion. True reality is devoid of time. It's like watching a movie. All the frames have already been recorded, but we experience them sequentially. Can time be an illusion? Physicist Julian Barber believes that time does not exist. According to his hypothesis, the universe consists of a multitude of moments, each of which is frozen, like a frame in a movie. We simply jump between these frames. If this theory were true, then the past, present and future would coexist simultaneously. Time in quantum physics at the microscopic level. In the world of quantum particles, time behaves very strangely. Particles can affect each other back in time, interacting instantly regardless of distance. Quantum mechanics allows for the existence of superpositions, where an event both happened and did not happen at the same time, up until the moment of observation. So, it is possible that time, at its deepest level, is not a smooth flow, but a set of infinite possibilities. The emotional impact of time. Humans have always sought to influence time. We build clocks, invent calendars, try to stop time through art, memory, and photography. But time is relentless. Every moment is unique. Every sunset will never be the same again. There is sadness in this, but there is beauty in it. Summary: time is more than we imagine. It is both a river and the deceptive surface of a mirror. It is both a sensation and a physical quantity. It is the story of our lives, recorded in the invisible fabric of the universe. Time may exist only because we perceive it, and whether it really flows or whether we ourselves are simply moving through an infinite canvas of possibilities is a question that has yet to be answered. Close your eyes. Feel the gentle waves of time carrying you on. Into the future, into the unknown, into infinity. The fundamentals of the physics of time. Einstein's theory of relativity. Imagine yourself flying in space, far from any stars or planets. All around you is boundless darkness and silence. Will time flow there the same way it does on Earth? Could it behave differently? What do we really know about time when we take away everything familiar from it? Discovering a new understanding at the beginning of the 20th century, humanity believed that the universe was simple and understandable. Space and time were stages on which events occurred, independently of each other. People built mechanical models of the world, like giant clockwork. But in 1905, a young patent office employee in Bern, Albert Einstein, appeared, who turned this whole system upside down with his thoughts. What is the special theory of relativity? Special relativity (SRR) explains how space and time work when objects move at a constant speed. Its basic principles are: the laws of physics are the same for all observers, regardless of their state of uniform motion. The speed of light in a vacuum is the same for everyone, regardless of the motion of the source or the observer. It seemed crazy at the time. But time and space were no longer absolute. They were changing. Time dilation. The twin paradoxon of the most surprising consequences of SRR is the slowing down of time at high speeds. Imagine two twin brothers. One stays on Earth, the other boards a spaceship traveling at close to the speed of light. When the space traveler returns to Earth, he will be younger than his brother. For him, only a few years have passed, while for his brother, decades have passed. This effect is called the twin paradox and is real, confirmed experimentally. Spacetime. Continue. According to Einstein, space and time are not separate things. They are combined into a single four-dimensional object, the spacetime continuum. Every event in the universe has coordinates: 3 spatial length, width, height, 1 temporal when it happened, and the movement of objects is movement in this four-dimensional space. The relativity of simultaneity. Another profound discovery. Two events that seem simultaneous to one observer may not be simultaneous to another. For example, imagine that you are standing in the middle of a train car, and lightning strikes both ends of the car simultaneously. For you, it is simultaneous. But for a passenger on the platform, watching the train in motion, the strikes occurred at different times. Time is not the same for everyone. It is attached to the observer. Why is the speed of light constant? Intuitively, we expect that if you run towards light, you will see it go faster. But in reality, it does not. Light always travels at the same speed, about 300,000 kilometers per second in a vacuum. This rule causes space and time to bend to maintain the constancy of the speed of light. Einstein's formula. E equals mc, the most famous formula in the world, derived from the SST. E equals mc squared. This means that mass and energy are two sides of the same coin. A small amount of mass can be converted into a huge amount of energy. This formula is the basis of nuclear power, as well as hypothetical technologies for creating time machines. Experimental confirmation. Special theory of relativity did not remain just a theory. It has been tested in numerous experiments. Atomic clocks on airplanes have shown that time does indeed slow down for them. Particles in accelerators live longer when traveling at high speeds. Navigation satellites take into account the effects of relativity to determine their location correctly. Without taking relativity into account, even GPS would not work. General relativity. The next step. A decade after the STT, Einstein created an even grander theory, the general theory of relativity (GTR). It describes how mass and energy warp spacetime. A large body, such as a planet or star, creates a dimple in spacetime through which other objects move. Time moves more slowly near massive bodies. Time flows faster at the top of a mountain than at sea level. Time almost stops near a black hole. Black holes and time affects a black hole in a place where the curvature of spacetime becomes infinite. Near the event horizon of a black hole. An outside observer will see your time slow down to a near complete standstill. This is not fiction, but a strict consequence of the house. And here the question arises, can such effects be used for real-time travel? EINSTEIN taught us that space and time are not a solid stage, but a living organism. They change, bend, stretch depending on motion, mass and energy. Time is not absolute. It is personal. Your time may not be my time. And therein lies one of the deepest mysteries of the universe. Close your eyes. Imagine your time flowing gently through space, leaving traces in the invisible fabric of existence. Are wormholes and portals in time possible? Doors between worlds. Imagine you enter a room through an ordinary door and come out in another galaxy. Or even in the last century. This is the idea of a wormhole, a tunnel in spacetime that could connect distant points or even different eras. But is it possible? Are wormholes a reality, or just a fantasy of science fiction writers? Theoretical basis. The Einstein-Rosen solution in 1935. Albert Einstein and his colleague Nathan Rosen developed a mathematical model that allowed for the existence of such tunnels. They were called Einstein-Rosen bridges or wormholes. They are based on the equations of the general theory of relativity. The idea is that spacetime can be warped to the point where short paths are created between distant places or moments. What would a wormhole look like? The structure of a wormhole hypothetically consists of two mouths, entry, exit points, a tunnel, a connecting throat that connects them. If you go into one mouth, you can instantly come out at another place in the universe or at another time. Imagine a piece of paper. If you fold it so that the 2 points touch, you go from one point to the other without covering a large distance. Energy problems, but building a wormhole has a huge problem. To keep the tunnel open, you need exotic matter with negative energy or negative mass. Ordinary matter, the kind we are made of, exerts gravitational attraction. And for a wormhole, you need something that creates gravitational repulsion. Otherwise the tunnel will instantly collapse. Is there exotic matter? We don't know if such matter exists at the moment. However, certain quantum effects, such as the Casimir effect, hint that under certain conditions, regions of space with negative energy can arise. This gives a small ray of hope. Theoretically, we may be able to find or create the necessary substance. Wormholes and time travel. If one lip of a wormhole is accelerated to a high speed close to light and then returned, according to the special theory of relativity, it will be younger than the other. As a result, the tunnel can connect different points in time. One end is in 2025, the other in 2500. You could enter one side and find yourself in the future or the past. Stability and safety. However, if we could create a wormhole, its stability is a big question. Will it withstand the passage of people or ships through it? Will it collapse instantly under the influence of ambient radiation? Many models show that instability is the main problem. It may be necessary to create special shields to hold the tunnel. Cinema and literature. Wormholes often appear in films. Interstellar 2014 is a brilliant example of a realistic depiction of a wormhole. Contact is based on a novel by Carl Sagan, which uses the idea of instantaneous travel. Even in science fiction, authors try to maintain physical authenticity by relying on real science. Will we one day build a wormhole? The reality is harsh. It requires enormous amounts of energy. Exotic matter is needed. We need technologies that we don't yet have, but the mere possibility of the theoretical existence of wormholes is already a grandiose breakthrough. Perhaps in the distant future, humanity will learn to control space-time. Conclusion: wormholes are not just fiction. They are real solutions to the equations of general relativity. Although they remain inaccessible today, in the future they may become the key to time travel. And here's the question: if we open a wormhole, will we dare to look the other way? Time travel paradoxes. Killing Grandpa or changing the world. What could go wrong? When we imagine time travel, it seems like it would be extremely interesting to visit the future, change the past, prevent tragedies, but upon closer analysis, terrible. Logical contradictions arise, paradoxes. The most famous of them is the grandfather paradox. What would happen if you went back in time and killed your grandfather before he conceived your father? What is the grandfather paradox? Imagine you travel to the past, you kill your grandfather for some reason. If your grandfather is dead, your father will never be born. If your father does not exist, you will never be born. But if you do not exist, then who killed your grandfather? This is a classic logical knot that seems unsolvable. Other paradoxes of time are in addition to the grandfather paradox. There are a few other striking examples. Information paradox. You receive blueprints for a time machine from someone in the future, build it, and then transmit the blueprints back to the past. Who created the blueprints in the first place? Causation loops. An event becomes its own cause. For example, you learn about a disaster in the future, go back in time, try to prevent it, and your actions accidentally cause it. Possible solutions. To paradox, science has proposed several theories for avoiding paradoxes. Novikov's consistency theory. Physicist Igor Novikov proposed a principle. Any events that occur in the past due to time travel cannot change the course of history in such a way as to create a paradox. In other words, no matter what you do in the past, the result will be that you will still be born. For example, your attempt to kill your grandfather will inevitably fail due to an unplanned circumstance. Multiverse. Infinite realisation. The idea is the many worlds theory. When you change the past, you don't change your past. You create a new alternate branch of reality. In the old universe, you still exist. In the new universe, you don't. So, by killing your grandfather, you are just creating a new universe where you don't exist, but your original timeline remains intact. Self-actualizati. Another concept. Time travel is already part of history. You were always there in the past, and your actions always caused what happened. You don't change the past, you create it. For example, by trying to save someone, you inadvertently become the cause of their death, as it was intended. Can we really change the past? Physics today does not provide a clear answer. If the principle of consistency is correct, then changing the past is impossible. If the multiverse is real, then you can create alternative realities, but you cannot change your universe. This question remains open and fascinating. Paradoxes in pop culture, in films and books. Time paradoxes are often a central theme. Back to the Future. Changes in the past change the future. The Terminator. A self-contradictory war between humans and machines through time travel. Dark. Netflix series. A detailed study of cause and effect loops. Fantasy creates different variations on the resolution of paradoxes. Philosophical reflections. Time travel raises difficult questions. What is fate? Do we have free will? Is it possible to avoid what has already happened? If everything we do is already written in space-time, do we really choose? Conclusion. Paradoxes of time demonstrate how complex and paradoxical our universe is. Time travel may be not only a technological problem, but also a challenge to the very nature of reality. And if one day we discover a way to travel through time, we will have to face the very essence of causality, choice, and fate. Maybe by changing the past, we will only fulfill our plans. Or maybe we will open an infinite number of new worlds. Time machines, concepts, and projects a dream of mankind. From the first myths to modern science, people have dreamed of the ability to travel through time. But what is a time machine in a scientific sense? Can it be built for real, and not just in fantasies? Let's try to sort out all the main concepts and ideas. What is a time machine? A time machine is a device or phenomenon that allows a person or object to travel to the past or future, different from the normal flow of time. Key characteristics: control, you decide where and when to go. Accuracy, you choose not only time, but also a spatial point, stability. The machine must withstand passage through time streams. Concepts for building time machines are several basic ideas. 1. Spacetime warping. According to Einstein's general theory of relativity, time and space are interconnected. Mass and energy can warp them. If we learn to control these warpings, it will be possible to create corridors in time. Wormholes are one example of such an approach. 2. Movement at the speed of light. Special theory of relativity says, the faster you move, the slower time passes for you. If you approach the speed of light, you can jump into the future. For example, 1 year will pass for you, and 100 for the Earth. But this is only movement into the future, not into the past. 3. Cosmic strings. Theoretical objects called cosmic strings can have such powerful gravity that they warp spacetime around them. If such strings are placed next to each other and made to move relative to each other, a time loop can be created. The theory was proposed by physicist Richard Gott. 4. Typler cylinder. Physicist Frank Typler proposed another model. A huge, massive cylinder rotates at close to the speed of light. It creates a gravitational field that wraps space-time around itself. Under the right conditions, it is possible to create closed time loops. Disadvantage: an infinitely long cylinder or incredibly high density is required. Technical challenge: even if a time machine is theoretically possible, gigantic problems arise in practice. Energy resources: more energy is required than is contained in the sun. Materials: exotic matter with negative mass has not yet been discovered. Stability control: even microscopic disturbances can destroy a machine. Risk of paradoxes: changing the past can have unpredictable consequences. Time machines in culture. Ideas about time machines have changed along with scientific progress. Classics: The Time Machine by H.G. Wells, 1895, is one of the first books to introduce the idea. Back to the Future 1985 to 1990 is a film series where the time machine is based on the DeLorean sports car. Modern examples: Dark. Netflix is a complex network of time travel through homemade machines. Tenet. 2020 is the idea of time inversion. Is it realistic to build a time machine today? Travel to the future by accelerating motion is theoretically possible. Time travel remains highly questionable. The main problem is energy and technological limitations, but physics does not categorically prohibit the existence of time machines. It simply says it is extremely difficult. Futuristic projects. Some scientists theorize possible ways, using black holes and their gravitational influence, creating mini wormholes in laboratories, manipulating quantum effects to build time tunnels. This is still a distant prospect, but research is ongoing. Ethical issue: 7. If a time machine becomes possible, difficult questions will arise. Is it possible to interfere with history? Who will control access to time machines? How to avoid abuse and catastrophic changes? Time travel could become the most dangerous discovery of humanity. Conclusion: time machines are more than just time travel devices. They defy the very laws of nature, logic, and philosophy. While the path to a real time machine may take hundreds or thousands of years, one thing is clear: humanity will never stop dreaming of conquering time. Is it possible that somewhere in the universe, someone is already traveling in time? Or are we ourselves the children of future travelers? Time loops: when events close in an infinite circle stuck in time. Imagine that you are experiencing the same day over and over again. Every time, everything starts the same way, regardless of what you did the last time. This is a time loop, one of the most mysterious and popular phenomena in science fiction and theoretical physics. What is a time loop? A time loop is a hypothetical situation in which a certain period of time is repeated infinitely, and the participants in this cycle may or may not be aware of the repetition. Key features: closedness, events return to the starting point, repeatability. Each cycle occurs in a similar way, possibility of change. Sometimes the participant can change the events with each repetition. How do time loops arise? Theoretically, time loops can be caused by gravitational anomalies, massive objects that distort time, quantum effects, entanglement of quantum states in time, technological devices, experiments with time machines or energy fields, unknown cosmic phenomena, for example, falling into a wormhole with a reverse effect. Theoretical models of time loops. 1. Closed time curves, CTC. Physicist Kirkdale described a solution to Einstein's equations in 1949 that allows for closed time curves. These are trajectories in spacetime that return an object to its own past. Under such conditions, time becomes cyclical. 2. Quantum time loops. At the quantum level, it is possible for particles to be in a state of superposition, including states with time inversion. Some hypotheses claim that quantum time loops could allow an object to interact with its past self. 3. Cosmic anomalies. It is assumed that certain conditions in the universe, such as the specific location of black holes or cosmic strings, can create time traps. There, events could naturally loop. Time loops in pop culture. Time loops are a favorite plot in movies, TV shows, and literature. Groundhog Day 1993, a classic film about the repetition of the same day. Edge of Future Past 2014, the hero dies and starts the battle from the beginning each time. Dark and ETFLIX. Time loops form a complex network of events between generations. Russian Doll of Flicks, a series about the endless celebration of one birthday. Such stories explore deep philosophical themes. Can a person change through endless repetition? What is true free will? How do time loops work in fiction? In fiction, loops often have the following features: trigger, an unusual event such as the death of a character or a disaster. Loop, the character wakes up at the starting point. Memory, sometimes the character remembers previous loops, sometimes not. Break, a way to escape the loop by changing behavior or achieving a goal. Physical limitations of time loop. Scientific models show several limitations. High instability. Even a small fluctuation can destroy the loop. Energy requirements. A colossal source of energy or gravity is required. Exotic matter. Matter with negative energy is required to maintain the structure. For now, time loops remain hypothetical phenomena. Time loop paradoxes with conventional time travel. Time loops raise questions. Causation paradox. If event A causes event B, and B causes event A, which one came first? Information paradox. Where does the information that is transmitted through the loop come from? These paradoxes make us think about the very nature of time. Time loops and consciousness. Some theories consider the question: if the loop affects the physical world, does human consciousness change? Can it transition between cycles while preserving memory? This poses new challenges to understanding memory and personality. Time loops and the multiversion hypothesis says each cycle in the loop creates a new branch of reality. Then there is no true repetition, only an infinite branching of options. In this case, the hero lives in a different world each time, even if he does not notice it. Conclusion: time loops are an amazing concept that allows us to rethink the nature of time, causality, and personal development. They are simultaneously a tool for exploring deep philosophical questions, a source of fantastic stories about endless attempts to change your life. Perhaps the very fact of our existence is already part of a large time loop. And every day is another attempt to find the right path. Traveling into the future. How physics allows us to peek ahead. The mystery of the future. Often think of the future as something unknown that lies ahead. But what if we could peek into it? Is it possible to travel in time and visit the future, changing our present? We live in an era when science allows us not only to fantasize about time travel, but also tries to understand how it can be implemented in practice. Traveling into the future, a theoretical possibility. According to Einstein's special theory of relativity, the future is absolutely real and available for study, but only with certain limitations. Movement at high speeds. According to the theory of relativity, When we approach the speed of light, time begins to slow down for us. This means that by traveling at enormous speeds, we can find ourselves in the future, although only a few years will pass for us. How it works. If you travel at 99% of the speed of light, 1 year of travel for you could mean 7 years for Earth. As a result, a person traveling in space can look into the future for several decades, or even centuries in one trip. Time barriers in travel. 1. Traveling into the future through gravitational distortion. Black holes, or supermassive objects, can create gravitational fields that distort time. Such objects can slow down time somewhat. Near black holes, time flows much more slowly than in distant points of the universe. Gravitational lenses and effects. Gravitational growth. If you get into such a zone, your clock will run much slower than on Earth. This means that you can travel to a black hole and return in a few years, but for other people on Earth, it will take much longer. 2. Time tunnels. If we talk about more exotic concepts, then one of them is space tunnels or wormholes. These are hypothetical structures that can connect different points in space-time. What does this do for future travel? If a tunnel is able to connect to distant points in time, it could allow travel to the future or the past. However, creating such tunnels requires very high energy and matter with negative energy, which is currently scientifically unattainable. Measuring time. How do scientists study the future? E1. Astronomical observations. Time travel does not necessarily mean physically moving into the future. It can be achieved through astronomical observations. When we observe distant stars and galaxies, we are actually looking into the past. The stars we see now may actually be millions of years older than our time, as the light from them travels through space. This allows us to study the future only at the level of cosmology and astronomy. But even so, we can learn what the universe will look like in many billions of years. 2. Atomic clock experiments. Science use atomic clocks, which measure time with high precision, to study the slowing down of time. These clocks allow us to record the difference in how the movement of an object affects the passage of time. For example, atomic clocks installed on airplanes show that the clock on the airplane slows down if the plane approaches the speed of sound or high speeds. This confirms that time actually changes depending on the speed and mass of the object. Is it possible to get to the future in practice? Of all the theories described, perhaps only a few work in practice in our current understanding of physics. Traveling at speeds close to light. At this stage, our technology does not allow us to approach the speed of light. Even the most advanced spacecraft, such as the New Horizons probe, travel at much slower speeds. However, if we could achieve such speeds, it would theoretically give us the opportunity to get into the future. Using black holes. Traveling to the future through black holes, of course, looks fantastic. Their incredible gravity could slow down time for the traveler. However, achieving such a technology or possibility in real life is not yet possible. Such travel to the future is, at the moment, only conceptual. Time and its philosophy. Time in physics is not just a measurement, it is also a philosophical concept. How do we perceive time? Is the future a real part of our lives, or is it just an abstraction? If we can travel to the future, can we change this time? Perhaps true time travel lies not in moving through centuries, but in the ability to change one's own attitude towards time. Conclusion. Traveling into the future is a possibility that scientists and science fiction writers have dreamed of. And although we are still limited by the laws of physics, science does not close the door to such events. So far, we can only approach the future with the help of theoretical models, technologies and discoveries, but the idea itself can inspire new achievements. Traveling into the past. Is it possible to change history? The art of changing the past. Each of us has wondered at least once in our lives, what if I could go back in time? What would I change in my life? How would world history change if we could correct mistakes or influence important events of the past? This question has occupied the minds of scientists, philosophers, and writers for centuries, and although modern science believes that traveling to the past is impossible, The theories and paradoxes arising from this concept are still very popular. Is it possible to travel to the past? Theoretical basis. Traveling to the past violates one of the basic concepts of physics, cause and effect. According to the classical laws of physics, every effect has its cause. If we can change causes, then this calls into question the very nature of our time. Time machines. One possible concept for time travel is the use of a time machine that can transport a person to a specific moment in the past. Black holes theories also suggest that black holes or their analogues could open paths to the past. Such travel could be based on the effects of gravity, which distorts time and space, the laws of physics, and the impossibility of time travel. According to the laws of thermodynamics, the universe is subject to time inevitability. We cannot go back in time, as this would violate entropy, the process of increasing disorder. But again, theoretical models allow us to imagine certain options that could violate these laws. Time loops. The possibility of violating the linearity of time arises through the concept of time loops, where events can close in on themselves and repeat themselves infinitely. Wormholes. There is also a hypothesis that the use of wormholes allows you to cut off parts of spacetime, allowing you to travel back and forth in time. Time paradox is one. The grandfather murder paradox, one of the most famous paradoxes that accompanies the concept of time travel, is the grandfather murder paradox. Imagine that you traveled back in time and accidentally killed your grandfather before he met your grandmother. If your grandfather died before you were born, then you could not exist to travel back in time and kill him. This causes a logical circle. You could not kill your grandfather because you could not exist. This paradox calls into question the very possibility of time travel, as it contradicts the basic laws of logic and causality. 2. The paradox of altered reality. In theoretical models, not only the outcome of travel changes, but also reality itself, which can be a multiverse or multiple parallel universes. Parallel universes. One theory suggests that changing the past can create a new branch of reality that does not violate the timeline of another universe. Thus, you can change events in one universe without encountering logical violations, since a new version of reality is created. 3. The paradox of time reversal. This paradox is that changes in the past can cause unpredictable consequences, which will subsequently lead to events that will change the very possibility of time travel. Selectivity of change. Each change in the past can lead to a series of events that will ultimately lead to even greater changes, which will already be unpredictable and indirect. How do time paradoxes work in pop culture? Time travel has become extremely popular in science fiction films that depict these paradoxes in visual form. Back to the Future 1985. This is a classic example of time travel being used to alter the past, leading to major changes in reality. 12. Monkeys 1995. A film about changing events, where attempts to change the future need to cyclical changes in events. Doctor Who 1963 present. This series explores numerous paradoxes of time, including the possibility of changing the past and the existence of parallel realities. These films use the concept of paradoxes to create interesting plots and also raise questions about the nature of time and free will. The ability to change history in real life. Can we really change history? History is the result of a series of events that have been determined by a multitude of factors, from human decisions to random circumstances. Traveling back in time and changing history means that we could influence global events that will change the course of humanity. However, real change is only possible through the discovery of new knowledge, technologies, and solutions. Perhaps changing history is happening in a more real sense than we think, through the achievements of scientists, scholars, and innovators who changed the course of human development. Conclusion. Traveling back in time, while fascinating from a scientific point of view, raises many philosophical and physical problems. They raise questions about causality, logic, and the nature of time. But perhaps changing history is already happening through our choices, through technological progress and cultural development. Perhaps we are already living as a result of those changes that once became possible when we began to realize our ability to change the future. Time as a dimension. From local observations to global concepts, time in different dimensions. Time is a fundamental concept in our lives. We are used to measuring it, using it for planning, understanding it as a linear flow from the past to the future. However, in different scientific contexts, time can be interpreted in completely different ways. From local observations to global concepts, time acquires different dimensions, which allows us to better understand its complexity. What is time? How can we measure and perceive this invisible factor that determines our existence? Local measurements of time. 1. History of time measurement. Humanity began to measure time in ancient times. Initially, they used natural cycles, the rotation of the Earth around the Sun, the phases of the Moon, to orient themselves in time. The first division of time into hours and minutes arose in ancient Egypt, where water clocks and sundials were created. Sundials used the shadow cast by objects to measure time during the day. Mechanical clocks. Over time, with the development of technology, mechanical clocks appeared that gave more accurate results and were able to divide time into smaller units. 2. Modern time measurement. Thanks to atomic clocks, today we can measure time with an accuracy of billionths of a second. This allows us to achieve extraordinary accuracy that our ancestors could not imagine. Atomic clock, based on the oscillation frequencies of cesium or rubidium atoms. This is the most accurate way to measure time, allowing us to correct even the smallest failures in the Earth's rotation or gravitational effects. Global concepts of time. 1. Time in the context of physics. In physics, time is one of the most complex and important concepts. Thanks to Einstein's theory of relativity, we understood that time is not an abstract and immobile dimension. It varies depending on the speed of the object and its mass. Time and space. According to the theory of relativity, space and time are interconnected. Therefore, when we move at high speeds, time slows down for us relative to those who remained on Earth. Time distortion. Time can also slow down under the influence of gravitational fields. The stronger the gravitational field, the slower time flows for an object in it. 2. The relativity of time in space. For astrophysicists, time is not only a means of measurement, but also an essential part of the study of the universe. By studying gravitational waves and black holes, scientists come to the conclusion that time in different parts of space can have different speeds. Black holes. In the vicinity of black holes, time slows down so much that for an object approaching the event horizon, an infinite amount of time can pass, while for an observer far from the black hole, only a few minutes will pass. Time and biological systems. 1. Biological clocks. There are biological systems that reflect our internal clocks. Circadian rhythms. They are responsible for regulating sleep, nutrition, and other processes that occur during the day and night. These rhythms are associated with the Earth's rotation and the solar cycle. They adjust the body to optimal activity during the day and rest at night. 2. Creating artificial time. With the development of technology, we have learned to create artificial time systems for convenience. For example, work schedules or study regimens. They allow us to manage time even in conditions of constantly changing natural circumstances. These artificial limitations may not always be comfortable for our bodies, as we often have to adapt to the conveniences and speeds of the modern world, which deviate from natural rhythms. Time and society. 1. Time in cultural context. Cultural perceptions of time can vary greatly depending on national traditions and philosophical views. Linear time. Western cultures traditionally perceive time as a linear process, from birth to death, from the past through the present to the future. Cyclic time. In many cultures, including India and ancient civilizations, time is perceived as a cyclical, recurring process. Birth and death, seasons, life and death of the world. 2. Time in the technological age. In today's world, with technological progress our view of time has also changed. We have begun to view it not only as a physical process, but also as a social resource. Technology and time, thanks to the development of the internet, smartphones, and social networks, we can now be constantly connected and interact with other people, which erases the boundaries of time and space. Today we live in real time, where information arrives instantly. Conclusion: time is a multidimensional phenomenon. Time is not just a linear dimension that flows from one event to another. It is a multidimensional phenomenon that can be studied from different perspectives: physical, biological, social, and cultural. It changes depending on the context, the speed of movement, the influence of gravity, and even the philosophical approach to perception. Perhaps time is not just a resource, but the key to understanding the very foundations of our existence and our place in space. Time and memory. How traces of the past are preserved. Memory, as a bridge between times. Memory is a complex and mysterious process that allows a person to retain information about events and experiences. It is a city between the past and the present, allowing us to experience events even when they have long passed. And although time is constantly moving forward, memory is able to preserve important moments of life that give our personality uniqueness and significance. But how does memory interact with time? How do we store and retrieve memories from our consciousness? And why do we sometimes forget the most important things? How does memory work? 1. Information storage processes. Memory can be conditionally divided into several stages: encoding, preservation, and reproduction of information. Encoding. This is the first stage, when the information we receive from the world around us is converted into a form that can be stored in our brain. This can be an auditory, visual, or sensory code that allows us to capture memories. Storage. Once information is encoded, it is stored in different parts of the brain in short-term or long-term memory. Storage is achieved through neural connections that are strengthened by repetition or the importance of the experience. Replay. When we want to remember something, the brain re-establishes connections between neurons, which results in the replay of memories. 2. Types of memory. Memory is classified into several types, each of which has its own role in preserving time. Short-term memory stores information for a short time, from a few seconds to a few minutes. This is necessary in order to process new information and interact with the world around us in real time. Long-term memory stores important memories for years or even a lifetime. These are memories of significant events that are of great importance to our lives. Automatic memory. It allows us to store memories that are part of our everyday experience, such as skills or habits. How are traces of the past stored? 1. Biological mechanisms of memorial brain works thanks to millions of neurons that process and store information. Each memory is a neural activity associated with certain electrical impulses. How is information stored at the physical level? Synapses and plasticity. Changes in synapses, connections between neurons, are the basis of memory. When we remember new information, the synapses become stronger, which allows us to store and retrieve memories. Memory consolidation. Over time, memories become more stable and are stored in the cerebral cortex, which allows us to retrieve information even after years. 2. Coding in the context of time. Time is not only a physical measurement, but also a context for our memories. We associate events with specific moments in time, which allows us to create a chronological picture of our memories. Spatio-temporal coding. Memories are often stored not only as images, but also with a specific temporal context. We remember what exactly happened at a certain moment in time, which allows us to relive these moments again. The temporal perspective of memory. 1. Memory as experiencing the past. One of the main functions of memory is the ability to relive the past. Memories are not only stored as static facts, but also provide the opportunity to experience the emotions associated with the event. When we remember something important, we not only restore the picture of the event, but also feel the emotions that were with us at that moment. sentimental and emotional connection. Memories associated with strong emotions are stored better and more vividly. Time in such memories has a tangible meaning. We return to that time, experiencing it again. 2. Memory as a basis for the future. Time not only determines what we remember from the past, but also helps us plan for the future. Memories give us a basis for expectations, plans, and decisions. They shape our beliefs and determine our actions in the future. Predicting the future, with the help of memory, we build an idea of what may happen in the future, based on previous experiences. Time in this case becomes important not only as experienced, but also as a context for building further strategies. Forgetting, a cleansing mechanism. 1. Causes of forgetting. Forget is a natural process that helps free the mind from excessive information. This allows us to focus on new important events, leaving only key points in memory. Forgetting due to interference. Some memories can interfere with others when new information overwrites old ones. Forgetting due to irrelevance. What we no longer use or need is erased from memory over time. 2. Psychological forgetting. Forget is not always a mechanical process. Sometimes we consciously or unconsciously forget events due to psychological factors, such as stress or trauma. Traumatic memories. The psyche sometimes blocks traumatic events to protect a person from emotional suffering. Memory and time. In culture. 1. Memory in literature and art. Memory is often a central element in literary works and artistic concepts. It becomes both a story and an interpretation of time. Works that describe memory show how we can manipulate time, change our perception of the past, or even create alternative realities through memories. Literature about time. Writers such as Marjorie Gardner and Virginia Woolf describe how memory can transform the perception of time, as well as influence the creation of interpretations of reality. Conclusion: time and memory are inseparable companions. Time and memory are interconnected, not only in a theoretical, but also in a practical sense. Memory allows us to experience time, preserve its traces, and recover experiences that might otherwise be lost to us. Memory, by preserving time, gives us the opportunity not only to live in it, but also to change our perception of it. Technology and time. How technology is changing our perceptions of time. Technology, as the new timekeeper's Nikola, has changed our understanding of time, allowing us to not only measure it with extreme precision, but also to change the way we interact with it. From the first mechanical clocks to modern smartphones and supercomputers, time has become for us not only an abstract concept, but also a resource that can be manipulated, controlled, and optimized. Conclusion: time in the age of technology. Nikola has radically changed our understanding of time. We are no longer limited to physical timekeeping devices or traditional calendars. From automated systems to biometric monitoring and virtual worlds, technology allows us not only to measure time, but also to redistribute it, speeding up or slowing down its flow. In the future, technology may further expand our capabilities in time management, changing not only how we perceive time, but also how we use it. How is technology changing our perception of time? What opportunities does it provide to speed up or slow down the rhythm of our lives? The revolution in measuring time. 1. The transition from mechanical to atomic clocks. Until the middle of the 20th century, people used mechanical clocks based on the rotation of wheels and springs to measure time. But over time, the development of physics allowed the creation of more accurate instruments, mechanical clocks, which have been used since ancient times, had limited accuracy. They measured time based on mechanical parts that could lose accuracy due to wear and tear. Atomic clocks. Modern atomic clocks use the vibrations of cesium atoms to determine time. These clocks can measure time to within 1/billionth of a second. Atomic clocks have not only made timekeeping more accurate, but have also opened up new possibilities for the development of technologies such as GPS and communication systems. 2. Virtual clocks and time on the Internet. With the development of the Internet, timekeeping technologies have become much more accessible and versatile. Virtual clocks allow us to control time regardless of physical limitations. Now, thanks to the internet, we can get the exact time anywhere in the world at any time. Time synchronization systems, protocols such as NTP, a work time protocol, make it possible to synchronize the clocks on computers around the world with incredible accuracy. Time as a resource in the modern world. Time in the digital economy in the modern world. Time has become an important economic resource. All processes, from the production of goods to the provision of services, are increasingly dependent on how quickly and efficiently time can be used. Automation, with the help of automated systems, such as artificial intelligence and robotics, we can significantly reduce the time for the production of goods and the provision of services, ensuring the fast and efficient operation of businesses. Internet of Things IoT. By connecting devices to the internet, time can now be optimized through the interaction between them. For example, in smart homes or factories, the time to complete certain tasks can be reduced by automating processes. 2. Time and social networks. Modern technologies allow us to interact in real time through social networks. This changes our perception of time. We are used to a constant flow of information, where every moment becomes important. Staying connected at all times is the new norm. Instant access to information. Thanks to smartphones and the internet, we have access to news, messages, and updates instantly. Accordingly, time has ceased to be linear. We live in real time. The impact of social networks on the perception of time. In today's digital world, we increasingly feel that time is compressed because everything becomes fast and accessible. This impact of technology on the perception of time is often called consumer time. Time tracking through technology. Time monitoring through biometrics. Modern technologies allow us to track time only through external devices, but also through biometric systems. For example, fitness trackers and smartwatches help a person monitor their physical condition in real time, allowing them to determine how their body reacts to time and stress. Health and time. With the help of technologies such as heart rate monitors, sleep trackers, and fitness apps, we can monitor our condition in real time, revealing the relationship between physical state and time periods. 2. Virtual time and virtual worlds. With the development of virtual reality and augmented reality, our ideas about time are beginning to change. Virtual worlds and games allow us to experience time in new ways. Game time. In video games, time can flow differently depending on what is happening in the game. Games can create a feeling of slowing down or speeding up time, which in turn changes our attitude towards it. Time in digital art and cinema. Editing and time manipulation technologies and editing and special effects technologies have changed our ideas about time in art. Cinema and digital art now allow the manipulation of time, creating slow motion or fast motion effects, as well as virtual time travel. Time in film, technologies such as CGI and motion capture allow the creation of scenes where time is perceived as plastic and changeable, which helps create the effects of time travel or time manipulation. Time in changing realities. Can we change our time? The reality we create time is one of the most mysterious concepts, and at the same time, one of the most accessible to us. For centuries, people have sought to understand how time works and whether it is possible to change it. If in science and philosophy, time is traditionally considered a linear phenomenon, then with the development of technology and new research, the question arises, can we manipulate time? From theories of changing realities to concepts of time travel, human imagination has created many options in which time may not be the way we're used to seeing it. But can science confirm the possibility of such changes? Time and the perception of reality. Perception of time through the prism of consciousness. Perceive time through our senses, but time is actually also a product of our mind. How do we perceive time? Why does time sometimes fly and sometimes seem to slow down? Emotional influence on time. Our emotions directly affect how we experience time. When we are happy, time often flies faster. While when we are experiencing stress or pain, time can drag on. Psychological plasticity of time. Time in our minds is not just a physical measurement. Sometimes we are able to slow it down or speed it up. Although external time remains the same, time and variables of reality in Theory 1. The theory of relativity and the possibility of manipulating time thanks to Einstein's theory of relativity. We know that time is not a constant and universal parameter. It is a measurement that can change depending on where and how we are. Reversal of time. One of the ideas proposed by the theory of relativity is that it is theoretically possible to go back in time if we move at a speed approaching the speed of light. Although this probably remains within the realm of theory, the concept that time can be changed based on speed and gravity is open to research. 2. Multiverse. Theorized multiverse, according to modern theoretical physicists, can include many different realities in which events can occur differently. Each possibility of events in our lives can create a new reality, parallel times. In the multiverse theory, there is the possibility of the existence of parallel realities where time moves along a different path. If this is the case, we can imagine that in another reality, we made different choices or even experienced completely different events. Time and reality variables in culture and philosophy. 1. Philosophical views on time manipulation. Philosophers have long been interested in the question of time and its influence on our lives. Thinkers of different eras have proposed different theories where time is not always linear. Plato and his concept of time. Plato believed that time is only a reflection of eternal ideal forms that are outside of time. Time in his understanding is only relative to the material world, and true reality is outside of time. Hegel and dialectical time. Hegel, on the other hand, viewed time as a dialectical process aimed at the development of the spirit and the achievement of absolute truth. Time in this context is not just a line, but part of a larger cyclical process in which everything changes, goes to a new state. 2. Time in popular culture. Popular culture has always been a field for experiments with time, starting from the great William Shakespeare and ending with modern fantastic works. Time has often been a tool for creating new worlds and reflections on the past, present and future. Time travel in cinema. Films such as Back to the Future, The Terminator, and Doctor Who explore the possibility of time travel, creating new realities based on how events in the past change. Time as a concept in literature. Authors such as C.S. Lewis and Aldous Huxley have also proposed alternative views of time, using it as a metaphor for moral, social, and personal change. Time, reality, and the future. 1. How we can change our perception of time. Perception of time changes not only through scientific theories, but also through the way we ourselves experience it. Perhaps it is our attitude towards time that we can change. Meditation and slowing down time. Through meditation and mindfulness practices, we are able to change our perception of time. Instead of constantly rushing, we can learn to be present in each moment, which changes our sense of time. Modern technology and time manipulation. With the help of virtual worlds, special programs and technologies, we can change the pace of time, or at least our perception of its speed. For example, in virtual realities, time can go much slower or faster, depending on how the conditions are set up. 2. Time travel, a theoretical view in real life. Theoretical possibilities of time travel exist only on paper, but the theory of alternating realities and multiverses gives hope that someday in the future we will be able not only to travel in time, but also to interact with parallel realities where time looks different. Time manipulation experiments. Today, scientists continue to explore quantum mechanics and gravity, which could lead to new discoveries in the field of time and its manipulation. Conclusion: time is a variable parameter of reality. I live in a world where time may seem fixed and unchanging, but with the development of science, philosophy, and technology, we are discovering that our ideas about time are only part of a larger reality. Time can be variable. Depending on the reality we choose or create. In the future, we will likely discover new ways to interact with time, and perhaps be able to change our perception and even the physical flow of time. Future time and technologies. What awaits us? The future of time in the world of technology. A future of time in the context of new technologies poses the question of whether we can not only measure time more accurately, but also change it. From artificial intelligence to biotechnology and the latest achievements in physics, scientific breakthroughs are opening up new horizons for manipulating time. How exactly can future technologies affect our perception of time? Are we really able to change its course? 1. The development of artificial intelligence and time. Artificial intelligence (AI) changing our perception of time, both in the context of human capabilities and from the point of view of information processing. AI is able not only to automate many processes, but also to accelerate the solution of problems, which significantly changes our sense of speed. 1.1 AI and time optimization. The future. AI can not only increase efficiency, but also radically change the very concept of time. For example, thanks to artificial intelligence that analyzes our habits, life can be planned in such a way that every minute is used to the maximum. Time personalization. AI can learn our habits, creating optimized plans for the day so that every moment is as productive as possible. And this does not necessarily mean a fast pace, but rather the correct organization of time to achieve the greatest results. Automation of routine tasks. Automation through AI allows you to reduce the time spent on routine tasks, which allows people to focus more on the creative and strategic aspects of their activities. 2. Biotechnology and time. Biotechnology is another area that can radically change the way we perceive time, affecting the biological processes of the human body and its ability to adapt. 1. Genetic engineering and life extension. Thanks to genetic engineering and biotechnology, we can achieve significant breakthroughs in medicine, which will allow us to increase life expectancy or even slow down aging. How will this affect our perception of time? Life extension. Advances in genetics may allow us to stop or slow down the aging process. Technologies that edit DNA may lead to the creation of new methods to extend human life. Prosthetics and bioimplants. With new technologies that allow the creation of bioimplants or the replacement of damaged organs, we can change the way humans interact with time. Time will not be associated with aging, but, perhaps, with renewal and restoration. 2. The impact of technology on the human perception of time. Biotechnology also changed the way we experience time at a physiological level. With the use of stimulating technologies, such as neurostimulators, we can increase our concentration, allowing us to speed up the workflow and reduce the time spent on tasks. Changes in the perception of time. Neurotechnologies can create virtual or augmented realities that change the perception of time, slowing it down or speeding it up depending on the user's needs. This could radically change our understanding of time when we can control its perception at the biological level. 3. The latest technologies in physics. Time as a variable parameter. Physics does not stand still, and today scientists are already considering the possibility of manipulating time through gravitational fields, quantum mechanics, and other theoretical concepts. 3.1 Gravity and changing time. According to Einstein's theory of relativity, time can change depending on how far away from strong gravitational fields you are. If we can store or create such fields artificially, we may be able to manipulate time by changing its speed. Time-altering technologies. In the future, technologies may be developed that allow us to create artificial gravitational fields that will slow down or speed up time, depending on the need. 3.2 Quantum mechanics and time observation. By delving deeper into quantum mechanics, scientists may discover new possibilities for manipulating time at the quantum level. This could lead to radical changes in our understanding of time, where we can change not only our perception of time, but also the actual course of events. Quantum computers. Quantum computers are capable of performing complex calculations, allowing us to analyze huge amounts of information faster. This, in turn, could change the way we interact with time, allowing us to plan our time and resources as efficiently as possible. 4. Virtual reality and time manipulation. Virtual reality, augmented reality (AR), and mixed reality (M) technologies that allow the creation of alternative realities where time can exist in a completely different way. 4.1. Time in virtual worlds. Virtual realities provide the opportunity to create time that moves at a different speed. For example, in games or training, time can be slowed down or sped up depending on the situation. Virtual time. Virtual time allows users to experience events at their own pace, creating ideal conditions for training or realistic simulations. Time in virtual realities can be radically changed to provide more effective learning or entertainment. 4.2. Mixed reality and time control. Mixed reality allows us to combine the physical and virtual worlds. This opens up new possibilities for manipulating time in the real world, allowing us to overlay virtual elements that can distort our perception of time. Time as an adaptive process. Mixed reality can change our perception of time by adding virtual elements to our reality. For example, we can observe virtual events unfolding in another time dimension, affecting our perception of real time. Conclusion: time and future technologies. Future of time is a limitless space for innovation. Technologies, from AI to quantum computers and virtual realities, open up new possibilities for manipulating time, giving us the power not only to measure it, but also to change it. In the future, we will likely see new methods of adapting to time, and even the ability to change its course. Time and artificial intelligence. Can machines feel time? Time in the world of artificial intelligence. Artificial intelligence (AI) has become one of the main engines of technological progress in recent decades. However, one of the most intriguing questions that arises with the development of this technology is whether machines can feel time in the same way that humans do. If so, how will they perceive this relentless flow of seconds, minutes, and hours? Today, we're used to the fact that time is an integral part of our lives. It determines our actions, schedules, and even emotions. But how do machines, which do not have human consciousness, react to this? Can they adapt to the concept of time? And if so, how might this change our interactions with them? 1. Time and artificial neural networks. 1.1. Algorithms and the sense of time. Artificial intelligence uses algorithms that can analyze data and make decisions, often much faster and more accurately than humans. However, these systems do not have an internal experience of time, as human consciousness does. Technologies that try to model the sense of time in AI are based on processing large amounts of information in a very short time. Time models in neural networks. Some neural networks are already trained to handle temporal dependencies in data. For example, in the case of video processing or analysis of serial data, temporal data, they can take into account how certain events change over time. Although the machines themselves do not have an internal sense of the passage of time, temporal awareness, for AI, the concept of time is mostly associated with algorithmic processing of information. While humans can intuitively experience time through emotions or physiological reactions, AI does not have such experience. 1.2. Machines and time adaptation. Thanks to the development of modern machine learning algorithms, AI is able to calculate and adapt its responses depending on time. But this adaptation is not a sense of time in the sense that we perceive it. Instead, these are computational models that are oriented to time intervals, time simulation. Although machines can be trained to a certain time of interaction or response, they do not feel time as we do. They simply work with time measurements and react to events in real time, but without subjective experience. 2. Time and object recognition. 2.1. Perception of changes over time. Artificial intelligence is actively used to recognize objects and situations over time. For example, in the field of autonomous cars and robotics, it is important to consider how objects change and their interaction over time. Autonomous systems, for self-driving cars and robots, time must be considered as a variable for safety and correct operation. This includes understanding how objects move and change over time, and how to make decisions based on temporal data. Time in computer vision. Computer vision systems using AI allow us to recognize objects in real time, taking into account how these objects change over time. However, this is not yet a sense of time. The machine simply processes input data without having an internal experience of the passage of time. 3. Artificial intelligence and artificial senses. 3.1. Imitation of human sensations create more advanced forms of artificial intelligence. Scientists are striving to imitate human sensations, including the sense of time. Although these attempts are currently quite limited, there are several approaches to how AI acquire a sense of time. Neural interfaces. With the development of neural interface technologies, it is possible to create a connection between artificial intelligence and the human brain, which will allow for improved adaptation to real time. This will allow AI to better understand and predict temporal changes. For example, in human behavior, machines with senses. Some research is aimed at creating robots with senses that allow them to feel their environment in real time. For example, through tactile sensations or specialized sensors. This could facilitate their adaptation to temporal changes in the environment. 4. Artificial intelligence in time studies. 4.1. Temporal model of artificial intelligence is actively used to create time models in many areas, from economic forecasts to climate change research. Modeling changes in time. Using AI, we can create mathematical models that take into account temporal aspects. This allows us to more accurately predict changes in systems, such as the weather or global economic processes. Although this involves computational analysis of time, AI does not perceive it as a phenomenon, interpreting the past and future. AI systems can also be trained on historical data and use time to predict future events. However, they do not experience time, but only perform calculations based on the data provided. 5. Can AI feel time like humans? The question of whether machines can feel time like humans remains open. Artificial intelligence has no subjective experience, so time is not an emotional or physiological experience for it. However, as technology develops, we may be able to create machines that will better mimic human perception of time. Machines that feel time. While AI can be trained to predict and account for time intervals, we cannot yet speak of machines having a real sense of time. Their feel of time is limited to algorithmic processing. Conclusion: artificial intelligence and the concept of time. Artificial intelligence is actively changing our understanding of time and our ability to work with it. Machines can analyze time and make decisions based on it, but they do not feel time the way we do. However, the development of neurointerfaces and biotechnology may lead to the fact that in the future AI will be able to interact more effectively with time, and perhaps even simulate its perception. Time and virtual worlds. How do technologies change our perception of reality? Virtual reality and new dimensions of time. Modern technologies are changing our understanding of reality, and in particular time. Virtual reality VR, augmented reality, AR and mixed reality allow us to create new worlds in which time can be perceived in a completely different way. Virtual environments not only change our understanding of the physical world, but also provide new opportunities for manipulating the flow of time itself. This chapter explores how technologies that create new realities can change our perception of time, how we experience it, and what the consequences of such changes may be for our lives. 1. Virtual reality. The illusion of time. 1.1. Creating time illusions in the virtual reality allows us to create environments that appear completely real, but are actually just a computer illusion. One aspect that can be manipulated in such environments is time. In VR, we can be in real time, observing events, or we can shift the course of time, speeding it up or slowing it down. Acceleration and deceleration of time. Virtual worlds can visually simulate the change of time, allowing users to feel that time in the environment is moving faster or slower than in real life. For example, you can be in a world where one moment in time corresponds to several months in the real world, or where a minute can last several hours, simulating the effects of aging and time. In virtual realities, you can not only speed up or slow down the passage of time, but also change the physical characteristics of objects or characters according to its flow. This can include visual effects that show how an object or character has changed over the years. 2. Augmented reality. Time in the real world to point 1. Adapting time in the physical world. Augmented reality AR adds virtual elements to the real world, which can change our perception of time. Because AR works in real time, users interact with time that is directly reflected in the real world, while integrating virtual objects and actions. Real-time enhancement. With AR, we can see a reflection of future events or changes that have not yet occurred in our physical world, but already exist in the digital reality. This creates a delayed time effect, where future events become visible in real time through augmented visual elements, transforming the perception of time in the real world. When augmented reality is integrated into our physical spaces, it allows us to change the perception of our real-world surroundings. Time can appear to be stretched when information appears gradually, or, conversely, accelerated when you get everything you need in an instant. 3. Mixed reality. Between time and space. 3.1. Interaction of the time dimension in mixed realities. Mixed reality combines elements of both virtual and real worlds. This allows you to create hybrid environments where time and space can work differently depending on the context. Time as an adaptive parameter. In mixed realities, we can create interactive environments where time can only be felt by the user. Through certain actions or scenarios, the user can change time through their physical movements or by choosing certain paths in the virtual environment. Time and space as interactive elements. In mixed reality, time can be interconnected with space, which allows you to expand the experience of reality. For example, you can change the speed of time to feel the difference between movement in different dimensions of reality. 4. Virtual worlds and time memory manipulation. 4.1. Memory system. In virtual worlds, virtual environments often include a memory system where events and actions that occurred at a specific moment in time can be stored or changed. This opens up the possibility of manipulating time, making it more flexible. Changes in time memory. Virtual worlds allow for the storage of memories of events, as well as the modification or replacement of experienced experiences. This allows users to relive the same events or change the course of time, distorting the facts that happened, creating new memories. Simulated time memories. New technologies allow the integration of virtual events into physical reality and even reproduce them in memory. As a result, the user can experience their experience as if time had been stopped or slowed down, which changes their perception of time. 5. Time and social interactions in virtual worlds. 5.1. Interacting with other people through time. Virtual worlds provide the opportunity for social interactions that are not limited by real time. In a virtual world, time can be synchronized or asynchronous, depending on how we want to perceive interactions with other people. Time zones in VR. In virtual worlds, interactions may not be tied to a specific time or even place. This means that virtual times can be different for each user depending on their physical location and the time they prefer to interact with others. Time indeterminacy in virtual space. In such environments, there is no strict time of day, so users can find their social moments without considering real time. This creates a freer and safer space for communication, in which time is a subjective element. Conclusion. transforming time in virtual realities. Virtual, augmented, and mixed realities offer us new ways to interact with time. Technologies not only change the very nature of time, but also allow it to be manipulated at the level of experience, memory, and interaction with other people. Time in these environments is not a fixed parameter. It becomes flexible, adaptive, and subjective, changing our perception of reality. Time in brain science. How does neuroscience study the passage of time? Time and the brain. Time is one of the most important aspects of our existence. But how exactly do we perceive time? Why do we sometimes feel that time passes quickly and sometimes slowly? How does the brain process the passage of time? And why can our sense of time change depending on the context? Neuroscience attempts to answer these questions by studying how the brain perceives and processes information about time. Studying the passage of time in the brain can help us better understand various aspects of human consciousness, as well as apply this knowledge in fields such as psychotherapy, neurology, and cognitive science. 1. The brain and its ability to measure time. 1.1. The brain's internal clock or brain is equipped with so-called internal clocks that allow us to estimate time, even without explicit external signals. These clocks control a variety of physiological processes, from heartbeats to sleep cycles, and play a key role in how we perceive time. Heartbeat cycles. One of the most basic forms of timekeeping is our heart rate. The brain can use information about our heartbeat to determine how much time has passed since a certain moment. This process happens automatically, and we don't even notice it. Sleep cycles. Another example of an internal clock is our circadian rhythms, which regulate our sleep and activity throughout the day. These rhythms not only help the brain orient itself in time, but they also regulate our energy levels throughout the day. 1.2. Psychological perception of time. The brain is also able to adapt its perception of time depending on the context. For example, when we are engaged in an interesting or exciting activity, time may seem to pass faster than when we are bored or waiting for something. Time dilation. In situations where we are waiting for important events, time can be perceived as freezing. This is due to increased attention to the little things around us and increased anxiety, which distorts our sense of time. Intense activity. In the opposite case, when we are immersed in a task or activity, our brain can forget to count time, and we feel that it passes much faster. This is a phenomenon known as flow, where a person is completely immersed in the process and loses the sense of time. 2. The neuroscience of time. How time is studied in the brain. 1. Neural mechanisms of time processing. One of the main directions in the neuroscience of time is the study of the neural mechanisms that allow the brain to sense and evaluate time. Scientists are investigating how different areas of the brain, such as the striatal system and the cerebellum, interact to shape our internal sense of time. The cerebellum and time control. The cerebellum, traditionally known for its role in coordinating movements, is also involved in time processing. Studies have shown that the cerebellum helps us maintain precision in estimating time intervals, which allows us, for example, to coordinate movements with musical rhythm or respond to events in real time. The striatal system. Another important area of the brain responsible for the sense of time is the striatal system. It is involved in processes related to long-term memory of time intervals and the coordination of movements that require precise time measurements. 2. Experiments on time estimation. Scientists have also conducted numerous experiments to understand how the brain estimates short and long time intervals. For example, tests can be used where participants have to estimate the duration of a certain event or the interval between two sounds. Altered perception of time in different conditions. Some experiments show that time is perceived differently depending on the physiological state, for example, during stress or fatigue. This suggests that the brain is not a universal measuring instrument and is able to change the perception of time depending on external factors. 3. Time scarcity and its effects on the brain. 3.1. Stress and the perception of time. When we are in a stressful situation, our perception of time can undergo significant changes. We often feel that time is passing extremely quickly or extremely slowly, depending on the level of stress and emotional tension. Stress and the slowing down of time. In critical situations, when we are experiencing stress, for example, in situations of danger, time can seem to slow down. This phenomenon is associated with the activation of the adrenaline system, which provides increased attention to the details of the environment and makes us be very attentive to every moment. Information overload. When the brain is overloaded with information or multiple tasks, we may feel like time is running away from us. This is because the brain does not have time to process all the information it needs and makes our perception of time more chaotic. 3.2. Cognitive impairments and time. Some cognitive impairments, such as Alzheimer's disease or dementia, can affect the perception of time. People with such impairments may be unable to estimate time or may experience it differently than healthy people. Disturbances in the sense of time. As neurodegenerative diseases develop, people may experience time as frozen or blurred. This is because the neural networks responsible for estimating time are damaged. 4. Time in consciousness. How the brain feels, the passage of time. 4.1. Subjective experience of time. The question of how the brain creates our subjective sense of time is one of the most fascinating topics in neuroscience. Time, as we experience it, is not an objective reality. It is only a construction that the brain creates based on the information it receives. Time and consciousness. Consciousness is the key element that allows us to experience the passage of time. The brain constantly generates a stream of thoughts, experiences, and emotions, and it is this stream that shapes our perception of time. The brain integrates all the sensations and events that occur at a particular moment into a single, coherent picture. Conclusion. The brain as a timekeeper. The brain is an incredibly complex organ, capable of estimating time and integrating the various factors that influence our perception of time. From how we measure time intervals to how stress or emotions can alter our sense of time passing, neuroscience is helping to uncover all of these aspects. Time in quantum physics, paradoxes and possibility. Time and quantum physics. Quantum physics, one of the most revolutionary and complex branches of science, challenges our classical understanding of time. In a world where time is usually perceived as linear and irreversible, quantum mechanics offers new, sometimes paradoxical concepts that can change our understanding of the very nature of time. In this section, we will consider how time challenges traditional understandings of reality and what quantum physics can say about the flow of time, in particular through concepts such as time loops, quantum entanglement, and universal time. 1. Fundamentals of quantum mechanics, time, and its roles in the microcosm. 1. Classical and quantum time. In classical physics, time is perceived as a linear quantity that runs from the past to the future, and our perception of time in the real world is largely based on this linear dimension. However, in quantum mechanics, time is not so obvious or defined. Quantum physics introduces new concepts where time becomes part of a more complex structure that includes the principles of uncertainty, superposition, and entanglement. Therefore, in quantum mechanics, the question of time acquires new, unique dimensions where the classical interpretation may no longer work. 2. Time in the context of quantum field theory. According to quantum field theory, all particles are not separate, independent objects, but exist as wave functions that propagate through space. Time in this case is not a simple variable that is separated from other physical quantities. In the quantum context, time is interconnected with space, forming a single fabric of the spacetime continuum. In this theory, time and space interact with each other through the gravitational field and quantum effects. Time becomes more flexible and adaptive, so processes that are not subject to traditional understanding can occur in it. Point 2. Paradoxes of time in quantum physics. 1. Time loops. Is it possible to go back in time? One of the most fascinating, but also paradoxical aspects of quantum physics is the idea of so-called time loops. Theoretically, with the help of special conditions, in particular in black holes or through quantum entanglement, it may be possible to create conditions under which a particle could go back in time. Time loops and black holes. Black holes are cosmic objects with such strong gravity that even light cannot escape from them. They can create conditions where space and time bend, which allows for the theoretical possibility of time travel. Mysteries and contradictions. While theoretically possible, time loops create paradoxes. For example, if someone goes back in time and changes events, doesn't that create a contradiction or infinite loop? This question is still open. 2. Quantum entanglement and time. Quantum entanglement is the phenomenon where two or more particles become interconnected in such a way that changes in one particle are instantly reflected in the other, no matter how far apart they are. Effect on time. This raises the interesting question of whether there is some universal essence to time. Entanglement may indicate that time at the quantum level may be organized differently than in the macroscopic world. For example, when particles are entangled, we can observe how the distance and time between them may not be so clearly defined. Quantum entanglement experiments. Numerous experiments confirm the existence of this phenomenon, but the question of how it interacts with our classical interpretation of time remains unresolved. Point 3. The Big Bang Theory and time. 1. Time at the beginning of the universe. If quantum mechanics challenges our perception of time on small scales, then the Big Bang Theory challenges our understanding of time on a cosmic level. According to the theory, time as we know it appeared at the moment of the Big Bang, about 13.8 billion years ago. Time as a property of the universe. The Big Bang Theory challenges the idea that time existed before that moment. That is, time, as a physical quantity, can be closely related to the universe itself, its origin and development. Space and time as one. According to the theory of relativity, space and time are on a single continuum that changes under the influence of mass and energy. Thus, time is not absolute, but depends on the conditions at each specific point in the universe. 4. Quantum ideas and future technologies. 1. Time in quantum computers. Quantum computers, using quantum bits qubits, can process information at enormous speed based on the principles of quantum superposition and entanglement. They could revolutionize the way we work with time in the context of data processing. The quantum paradox of time. Quantum computers could potentially break the linear understanding of time, allowing us to process a multitude of possible options simultaneously. This changes our attitude towards computation and time as a resource that is subject to constraints. 2. Time in quantum technologies. We deepen our understanding of quantum phenomena. It could lead to new technologies that allow us to better control and manipulate time. In the future, this could include developing technologies for ultra-fast information transmission or even new ways to manipulate time through quantum entanglement. Conclusion. Time in quantum physics. Mystery or opportunity. Quantum physics has shown that time is not the simple, linear dimension we used to think of. It challenges many of our usual assumptions and opens up new possibilities for understanding not only how the universe works, but also how our relationship to time change in the future. Time in psychology. How our brain perceives the past, present and future. Psychology of time. Time is not just a physical quantity delivered by clocks and calendars. For humans, time has enormous psychological significance. How do we perceive time? How do we experience the past, present and future? How does our brain process time? And why can our perception of time sometimes be so subjective? Psychology of time studies how we experience various aspects of time, from how quickly or slowly time passes in different situations to how time affects our emotions, memory and decisions. 1. Observation of time. Subjective perception. 1. Why can time seem fast or slow? Time can be perceived differently depending on many factors, including our emotional states, concentration, and even physiological processes. For example, when we are engaged in something exciting and enjoyable, time can fly and we do not notice how quickly it passes. On the contrary, when we are stressed or bored, time can seem very slow. The psychology of time considers this phenomenon through the concept of time relativity, where our brain adapts to certain conditions, changing our perception of the passage of time. One such phenomenon is the so-called time distortion effect, which is explained by changes in the activity of neural networks in the brain. 2. Stress and the perception of time. When we experience stress, our brain works more intensively, in particular due to increased adrenaline levels. This can affect how we perceive time. In stressful situations, people often feel that time passes more slowly, especially when they are waiting for an important moment or experiencing some kind of danger. Studies show that during times of high emotional stress, such as anxiety or fear, the brain can expand its sense of time because it focuses more on processing detailed information. This can make it seem like more time has passed than it actually has. 2. Time in memory. How we experience the past. 1. Memory and time or perception of the past is not simply a chronological retelling of facts, but a process that is actively formed and changed in our minds. How we store and recall memories of the past depends on how our brain organizes this information. Memory is not a static process, and it is constantly changing. This means that our memories of the past may not always be accurate. Sometimes we distort details or add new elements to memories, depending on how time affects our psyche. 2. Selectivity of memory. Time also affects what we remember. For example, events that have become important or emotionally meaningful to us may be retained in our memory longer. At the same time, less significant moments may be forgotten or blurred over time. This can create the illusion that time has passed faster because we do not remember small things that did not have a big impact on our lives. 3. Time in decision-making. The future and anticipation. 1. The brain and anticipating the future. How do we plan for our future? How does the brain process and evaluate the possible consequences of our decisions, taking into account the future? One important aspect of the psychology of time is how we predict what will happen, and how this anticipation affects our actions. Research shows that our brains often engage in anticipating future events based on experience and existing knowledge. This process helps us adapt to a changing world by anticipating different possibilities and choosing the most advantageous ones. 2. Time management strategies. Another important aspect of the psychology of time is how we allocate our time between different tasks. This includes the planning and time management strategies we use to achieve our goals. For example, procrastination. The tendency to put off important tasks until later is one of the future-related phenomena that has a major impact on our perception of time. Psychologists also study how this procrastination affects our productivity and sense of time. Procrastination can create the feeling that time is flying by because we don't complete important tasks that remain undone and accumulate. 4. Time in the context of personal development. 1. Development and change in time. Time is an important factor in personal development and our perception of the world. The older we get, the more our understanding of time changes. For young people, time can seem endless, while for older people, it can seem to shrink. This is due to how our goals, our interests, and the ways we interact with the world around us change. personality development and a changed perception of time help us understand why at certain stages of life we set different priorities, make different decisions, and perceive time differently. *2. Psychology of age and time. The psychology of time also studies how different age groups perceive time. Children and young people perceive time differently than middle-aged and older people. As people age, they tend to feel that time passes faster, which is related to how their perception of life, social connections, and physical condition changes. Conclusion: time as an emotional and psychological dimension. Time is not only a physical quantity, but also an important psychological and emotional resource. How we perceive time depends on many factors, including our emotions, memory, decision-making, and even age. The psychology of time helps us understand how the brain works with these aspects and why our perception of time can be so subjective. Time in culture. How different peoples perceive and measure time. Time in a cultural context. Time is a concept that not only determines when events occur, but also has a profound meaning in each culture. In different parts of the world, people perceive and organize time differently, and these differences can affect their social interactions, work habits, and even the very structure of society. How is time measured in different cultures? What are the peculiarities of time perception in different peoples? This section is devoted to analyzing how time is reflected in the cultures of the world, from the influence of calendars to unique cultural concepts of time, such as linear or cyclical time. 1. Linear time and cyclical time. 1. Linear time in Western culture. In most Western cultures, particularly in Europe and the United States, time has traditionally been perceived as linear. This means that time moves forward in a continuous flow, where the past is already complete, the present is what is happening now, and the future is what is yet to come. This approach to time is often associated with the idea of progress, development, and the achievement of goals. The linear perception of time can be seen in the way our calendars are organized, work schedules, and in many social structures where deadlines play an important role. 2. Cyclical time in Eastern cultures. At the same time, in some Eastern cultures, such as Hinduism, Buddhism, or Taoism, time is perceived as cyclical. The cyclical view of time means that all events, life, death, and rebirth, have a cycle and repeat themselves at certain intervals. This is embodied in rituals, celebrations, and even in the belief that the lives of people and the universe follow a certain cycle. In cultures with a cyclical understanding of time, the concept of eternal return is important. The idea that time and events return to their original state, revolving in an endless circle. 2. Calendars and time measurement. 1. The Gregorian calendar, a global standard. The Gregorian calendar, which is the international standard, plays a huge role in measuring time today. It is based on astronomical calculations and is a solar calendar where the year is divided into 12 months, each of which consists of 30 or 31 days, except for February, which has 28 or 29 days. The Gregorian calendar sets clear dates for holidays, working days, and deadlines, making it the main tool for organizing time in most countries of the world. 2. Lunar and other calendars. However, not all cultures use a solar calendar. For example, Muslim countries use a lunar calendar, where the year consists of 12 months, each of which has 29 or 30 days, which gives a total of 354 or 355 days per year. The lunar calendar differs from the solar calendar in that its cycle does not correspond to the complete revolution of the Earth around the Sun, which leads to a shift in the dates of holidays and seasons over time. There are also various local calendars, such as the Chinese calendar, which combines both solar and lunar cycles and is used to determine traditional holidays, such as Chinese New Year. 3. The relationship between time and social norms. 1. Time and punctuality in Western cultures. In many Western countries, such as Germany, the United Kingdom, and the United States, punctuality is an important social norm. Time is seen as a limited resource, and therefore being on time is a sign of respect for other people and efficiency. Western culture also places great emphasis on a clear allocation of time. This can be seen in business, education, and everyday life, where planning and strict adherence to schedules are important aspects of social norms. 2. Time and the relative attitude towards it in Latin American countries. In Latin American countries, such as Mexico or Brazil, social norms regarding time are less strict. Although there is a certain punctuality in business, there is often a more relaxed approach to time in everyday life. This is manifested in the fact that people do not always strictly adhere to a schedule, which can sometimes lead to delays in meetings or celebrations. In such cultures, time may be perceived as more elastic, with a greater emphasis on interaction and enjoying the moment rather than on adhering to rigid rules and deadlines. 4. Holidays and rituals. How different people celebrate time. 1. The culture of holidays and annual cycles. Many peoples around the world celebrate specific moments in time that are related to natural cycles, the changing seasons, harvests, religious events, or traditions. For example, the traditional Chinese New Year is based on the lunar calendar and is celebrated at different times each year, depending on the lunar cycle. Other peoples, such as the Indians of Central and South America, also celebrate moments related to natural cycles, using their own calendars that reflect a cyclical approach to time. 2. Religious celebrations and religious celebrations, such as Christmas, Easter for Christians, Ramadan for Muslims, or Diwali in India, define not only the annual cycle, but also the place of time measurement. In spiritual life, in these cultures, time is not only a social and organizational factor, but also has a deep spiritual meaning, reflecting cycles of birth, rebirth, repentance, and celebration. Conclusion: time as a cultural phenomenon. Time is not only a physical or abstract quantity, but also a cultural phenomenon that has different meanings in different cultures. Linear or cyclical perception of time, different calendars, and social norms related to time determine the way people live and interact in different parts of the world. A deeper understanding of how time is perceived in different cultures allows us to better understand the worldview of peoples and find commonalities and differences in our shared experience of time. Time and technology. How technical innovations are changing our understanding of time. The impact of technology on the perception of time. Technology is changing our understanding of time, from how we measure time to how we perceive and use it. In the past, humanity was limited to natural rhythms, such as the sun and moon, to organize time. But with the development of technology, our perception of time has become more mechanized and precise. From the first clocks to mobile phones, from traditional calendars to digital platforms, technology is significantly changing the way we relate to time. In this section, we will consider how innovations in various fields are changing our perception of time and what new opportunities for time management are opening up thanks to modern technology. 1. Time and clocks. From hourglasses to atomic clocks. 1. Early ways of measuring time. In ancient times, people measured time using natural phenomena, such as the position of the sun in the sky or the changing phases of the moon. The first mechanical clocks appeared in Europe in the Middle Ages, and they allowed for more accurate timekeeping. Hourglasses and water clocks were also used to tell time. Over time, with the development of mechanical technology, clocks appeared that provided more accurate time information, which allowed people to plan their affairs and events more accurately. 2. Atomic clocks. Precision without limits. With the beginning of the atomic era in the mid-20th century, atomic clocks were developed, which became the basis for accurate timekeeping around the world. Atomic clocks work on the basis of the properties of atoms, namely their oscillations, which allows for extremely high accuracy in determining time. They are used for global navigation systems, GPS, and scientific research, where an extremely Accurate measurement system is required. These technologies allow for time measurements down to nanoseconds or less, enabling revolutionary advances in science, such as precise navigation and planning systems. 2. Time and digital technologies. From smartphones to online services. 1. The impact of smartphones on the perception of time. With the advent of smartphones, technology has become accessible to almost everyone, and with them our relationship to time has changed. Smartphones provide accurate real-time time measurement, allowing us to receive information about train schedules, taxi orders, news and weather at any time. These devices are also convenient for time planning, as mobile applications allow us to keep a calendar, set reminders and organize our workflow. This gives users more freedom in managing their time, but can also lead to a feeling of overwhelmed due to constant messages and requests. 2. Online services and digital platforms. The Internet and digital platforms have also changed our understanding of time, providing new opportunities for interaction. For example, online meeting platforms such as Zoom, Skype or Google Meet allow us to communicate with people around the world at any time of the day, completely changing the concept of time and place. Online services also allow us to adapt our time for work, study and leisure, regardless of where we are. This leads to more flexible schedules, but can also lead to problems with work-life balance. 3. Time and automation. How artificial intelligence is changing time management. 1. Artificial intelligence and its role in time management. Artificial intelligence (AI) becoming an increasingly important part of our lives, automating many processes and changing the way we interact with time. AI can optimize our schedules, plan routes, organize workflows, and even help us make decisions by analyzing large amounts of data. For example, AI assistants such as Siri, Google Assistant, or Alexa help people save time by performing tasks that previously took more effort, such as reminding them of important meetings or searching for information. 2. Automated workflows. In the automation of manufacturing, business and other areas, time is significantly reduced thanks to robots and software. This allows to reduce the time required to complete tasks, reduce costs, and increase efficiency. For example, in the logistics sector, automation forms the basis for the distribution of goods and deliveries, ensuring speed and accuracy. At the same time, automation can cause challenges, including in terms of job retention and resource allocation. 4. Time on social media. Speed and immediacy. 1. Real-time and social media. Social media has changed our perception of time, turning it into an instant, continuous stream of news and updates. With platforms like Twitter, Facebook, Instagram, and TikTok, we have constant access to information and events in real time. This is changing not only how we perceive time, but also how we interact with other people. News that used to have a longer relevance period is now instantaneous, and anyone can access this information in seconds. 2. The impact of the speed of information exchange. The speed at which people can exchange information contributes not only to changing the perception of time, but also to the pace of life itself. Instant messaging, access to news, media, and entertainment content create the effect of constant presence and change the feeling that every moment should be filled with something important and new. Conclusion: technology and our perception of time. Technology has significantly changed our understanding of time, from precise measurement of it to more flexible approaches to planning and managing time. Mobile technologies, automation, artificial intelligence, and social networks are changing how we interact with time, but also pose new challenges in balancing speed and efficiency with quality of life. With each new technology, the way we perceive time is getting closer to the instantaneous and global scale, which opens up new opportunities, but also raises questions about our relationship with time in the future. Time and physics. How the science of time changes our understanding of the universe. Time in the context of physics. Time is one of the most important yet also the most mysterious, concepts in physics. In everyday life, we perceive time as a linear, continuous flow that simply flows. However, when we look at time through the lens of the laws of physics, including the theories developed by such prominent scientists as Albert Einstein, we begin to understand that time is not as simple and obvious as it seems at first glance. In this chapter, we will consider how physics views time, from classical mechanics to quantum theory and the theory of relativity, and how these theories have changed our understanding of time, space, and the universe. 1. Time in classical mechanics. 1. Isaac Newton and absolute time. In classical mechanics, developed by Isaac Newton, time was understood as an absolute quantity that flows the same way for all observers at all points in space. Newton believed that time flows without change, and its measurement does not depend on where and how we are located. This understanding of time as an absolute quantity became the basis for much scientific research in the 18th and 19th centuries. However, this idea of time was later changed with the development of new theories, in particular the theory of relativity. 2. The theory of relativity, time and space as a single continuum. 1. Albert Einstein and the special theory of relativity. The special theory of relativity, proposed by Albert Einstein in 1905, radically changed our understanding of time. According to this theory, time is not universal for all observers, but depends on their motion. The key point of this theory is the concept that time and space are interconnected, creating a single four-dimensional continuum, spacetime. One of the most famous results of the special theory of relativity is the effect of time dilation. When an object is moving at high speed, time passes more slowly for it compared to those who are at rest. This effect has been confirmed by numerous experiments, such as observations of atomic clocks moving at high speeds. 2. General theory of relativity, gravity and time. The general theory of relativity, which Einstein published in 1915, further expanded our understanding of time. It states that gravity is not a force, as previously thought, but the result of the curvature of spacetime caused by the mass of objects. This means that time can slow down in strong gravitational fields, such as near black holes or very massive stars. This effect of gravitational time dilation has also been experimentally confirmed. For example, atomic clocks located on the surface of the Earth and at high altitudes, where gravity is weaker, show a difference in time, because time on the surface of the Earth passes slightly more slowly. 3. Quantum mechanics, time in the world of MICROPATICLES. 1. Time and uncertainty in quantum mechanics. Quantum mechanics, which describes the behavior of particles at the atomic and subatomic levels, further complicates our understanding of time. In classical mechanics, time could be measured precisely and directly, but in quantum mechanics, things are much more complicated. The basic principle of quantum mechanics is Heisenberg's uncertainty principle, which states that there is a limit to how accurately certain pairs of quantities, such as the position and velocity of a particle, can be measured simultaneously. This raises the question of whether time is as precisely defined a quantity in the quantum world it is in the quantum world, or whether it is merely a probability quantity, other quantum parameters. Quantum mechanics forces scientists to question the linearity of time that we perceive in the macroscopic world. 2. Time in quantum theories of gravity. Quantum gravity is a branch of physics that attempts to unify the theories of quantum mechanics and general relativity, and this question is one of the greatest challenges in modern physics. Since gravity does not behave at the level of quantum particles in the way we are used to seeing it in the macroscopic world, scientists are trying to understand how gravity and time interact on such a scale. One approach is the concept of quantum time, where time is viewed not as a continuous flow, but as discrete, composed of minimal unitary steps or portions. similar to how elementary particles can only exist in certain quantum states. 4. Time and black holes. The limit of time. 1. Time in black hole fields. Black holes are cosmic objects whose gravity is so strong that even light cannot escape their gravitational field. This creates a unique situation for time. In black hole fields, time slows down considerably for objects approaching the event horizon, a boundary beyond which even light cannot escape. This effect, called gravitational time dilation, has been the subject of numerous theoretical studies, and is confirmation that time is not universal and can be very distorted under extreme conditions. 2. Time in the theory of curved timelines. There are also theoretical models that predict that under certain conditions time can twist or even become cyclical. This can happen in black holes, where space-time can be bent to such an extent that time travel scenarios or even past changes are possible. Conclusion: time as a part of physical relativistics provides us with a deep and multifaceted understanding of time, from its absolute nature in classical mechanics to the complex and often paradoxical properties of time in quantum mechanics and the theory of relativity. Time is no longer simply a measurable quantity, it has become an integral part of the structure of the universe, defining its space and interactions at the deepest levels. Understanding time as a part of physical reality opens up new possibilities for exploring the cosmos, our place in the universe, and even the possibility of time travel. Time in philosophy. How different philosophical schools interpret time and its nature. Philosophy of time. Time is not only a scientific, but also a philosophical concept that forces us to think about its nature, meaning, and how we perceive it. For centuries, philosophers have tried to answer the question of whether time is an objective reality or just a subjective sensation. Views on time in philosophy reflect our ideas about space, existence, change, and even the very essence of reality. In this section, we will consider how different philosophical schools interpret time, ranging from ancient views to modern theories. 1. Ancient Greek philosophy. Time is changeability. Y. 1. Heraclitus and the idea of constant change. One of the first philosophers to pay attention to time was Heraclitus. He believed that everything in the world changes and moves, and that this change is the basis of being. Heraclitus argued that it is impossible to step into the same river twice, because the water is constantly changing, and in the same way, time does not remain constant. This view of time as a stream that is constantly moving and changing became the basis for many philosophical concepts about the nature of reality and change. 2. Plato and eternal ideas. Plato, on the other hand, presented time in the context of his theory of ideas. For him, time was only a reflection of eternal ideal forms. In his views, time was not an independent reality, but rather a reflection of eternal perfection that exists in a world of ideal forms that are beyond the limits of ordinary human perception. Plato argued that the real world is the world of ideas, and what we perceive as time is only a copy of this higher, timeless reality. 2. Christian philosophy. Time as part of the divine plan. 1. Augustine and the question of the nature of time. Augustine, one of the most famous Christian philosophers, expressed one of the most profound reflections on time in his writings. He recognized that time is a fundamental aspect of our existence, but at the same time, it is difficult to define. Augustine wrote that time exists only in the minds of people. He argued that the past is no more, the future has not yet come, and we live only in the present, which is only an involuntary perception of these two other dimensions. He asked the question, if God exists outside of time, how can he then act in time? This question remains one of the most profound in the philosophy of time. 2. Time and God's plan. In the Christian tradition, time is seen as part of the divine plan. God is eternal and timeless, but the creation of the world and the incarnation of Jesus Christ in time led to an important change and in the understanding of human history. Time became linear, having a beginning, creation, and an end, the kingdom of God. This understanding of time as history, which has its purpose and goal, changed many philosophical concepts. 3. Modern philosophical concepts of time. 1. Immanuel Kant and time as a form of perception. Immanuel Kant, one of the founders of German classical philosophy, approached time from the point of view of human cognitive processes. In his work Critique of Pure Reason, Kant argued that time, along with space, is not a property of objects, but a form of our perception of reality. According to Kant, we do not know objects in their direct form, but through the prism of our mental categories, among which is time. This means that time is not something that exists independently of us, but is a condition that allows our mind to organize the perception of events in the real world. Therefore, time is not an objective reality, but a structure of our perception. 2. Martin Heidegger and being in time. Martin Heidegger, a German existentialist philosopher, considered time as an integral part of human existence. In his work, Being in Time, Heidegger argued that human existence is being in time. Time is what defines our existence, and it is thanks to time that we can make sense of our existence. Heidegger believed that we are always in the future that precedes our actions, and that time is the basis of our ability to experience life. According to his concept, we cannot get out of time, and it is the awareness of the limitations of our existence in time that helps us understand the meaning of life. 4. Time in contemporary philosophical debates. 1. Linearity or cyclicity of time. Contemporary philosophers sometimes consider the question of whether time is linear, from past to future, or cyclical, in some Eastern religions, such as Buddhism or Hinduism. The linear perception of time is often associated with the idea of progress, history, and development, while the cyclical view of time emphasizes recurring cycles and rebirth. This question is closely related to the concepts of causality and changeability. Scientists and philosophers often debate whether time is simply a sequence of changes, or whether it is a more complex and structured reality. 2. Time in postmodernism. Postmodernism, in particular philosophers such as Jean-François Lyotard and Jean Baudrillard, propose new concepts of time, including its discontinuities and absorption. They argue that we can no longer think of time as a single, continuous flow, as modern culture and technology create new forms of time perception where there is no clear linearity, but rather a multitude of parallel, non-sequential time streams. Conclusion: the philosophy of time as a window into understanding human existence. Time in philosophy is not just a technical or scientific category. It is the foundation on which our ideas about being, change, and development are built. From different philosophical perspectives, time can be linear or cyclical, objective or subjective, which emphasizes its multifaceted nature. Understanding time helps us make sense of our life experiences, our choices, and our mission in the world. Time is not only a unit of measurement, but also an important component of our philosophy and understanding of reality. Time in literature. How writers portray time in their works. Time in the world of art. Time in literature is not just an external factor that determines the sequence of events, but becomes a deep philosophical and artistic element. Writers, like philosophers, reflect on time, its influence on a person, his consciousness and perception of reality. Time in literature often appears as a flow that is not subject to strict linearity, but can be disturbed, changed, or even stopped for the duration of the story. This section is devoted to how various writers use time in their works, changing its form and meaning to achieve certain artistic goals. 1. Literary time, linearity or chaos. 1. Linear time in classical literature. In classical literature, in particular in epic works and dramas, time is often depicted linearly. Events unfold in a certain sequence, one after the other, according to the chronology of the characters' lives. This reflects the idea of progress, development, and change, where each stage is a consequence of the previous one. Classical works such as Homer's Iliad and Odyssey, as well as the tragedies of Sophocles, are built on the idea of linear time, where each event is a necessary step in the development of the plot. However, even in these works, there are often violations of time that add depth and make the reader think about its nature. 2. Disruptions of time in modernism. In modernism, especially in the works of authors such as James Joyce, Virginia Woolf, and Marcel Proust, literary time loses its linearity and consistency. They began to use complex and fixed structures of time that allowed the reader to experience chaos and continuous changes in the minds of the characters. For example, in James Joyce's novel Ulysses, time does not simply move linearly, but is intertwined with the characters' internal experiences. Joyce uses the stream of consciousness to show how different moments in time can overlap, thereby creating a complex and changing image of reality. 2. Time manipulation techniques. 1. In-depth experience of time through interior monologue. One of the most striking methods of using time in literature is interior monologue, which allows the author to reflect in depth the character's subjective perception of time. In novels such as All Quiet on the Western Front by Eric Maria Remarque or James Joyce's Ulysses, interior monologue allows characters to experience time not as a sequence of external events, but as a continuous stream of thoughts, memories, and experiences. This method allows writers to show how time can be changed and perceived through subjective sensation. Characters may experience time as a moment in eternity or, conversely, immerse themselves in memories that become part of their present experience. 2. Fictional time and parallel worlds. In the genre of science fiction, as well as in works where reality and fantasy mix, time can become fictional or paradoxical. Writers create their own time dimensions or use the concept of parallel worlds where time flows differently. In works such as George Orwell's 1984 or H.G. Wells' Time Travel, time has different rules and often violates the usual chronology, which provides an opportunity to explore the concepts of freedom, control, and limitation. 3. Time as a metaphor and symbol. 1. Time in poetry. Poets often use time as a metaphor to express various aspects of life, from love to death. In poetry, time can be not only an element of the plot, but also a deep symbol. Poems can depict time as fleeting, constantly changing, or as eternal, never-ending. For example, in the poetry of William Shakespeare, especially in his sonnets, time is often depicted as a force that destroys beauty and youth, but at the same time it inspires creativity. Time becomes a symbol of change, loss, and even the possibility of renewal through art. 2. Time and the symbolism of death. Time is often associated with death, and in literature this connection is often a central theme. Works such as F. Scott Fitzgerald's The Great Gatsby depict time as an inevitable process leading to an end. Death, in fact, becomes part of the very understanding of time. Everything has a beginning and an end. Time in such works can also be represented through landscapes or changes in the environment, symbolizing movement towards an inevitable end. Literary time and death become inextricably linked themes explored through the experiences of characters. 4. Manipulation of time in contemporary literature. 1. Time in postmodern works. In postmodern works, time is usually fragmented and unpredictable. Famous postmodern writers, such as Thomas Pynchon and Kurt Vonnegut, disrupt the traditional temporal structure, where events follow the logic of chronology. For example, in the novel Elephants Dancing on a Wire by Thomas Pynchon, time appears as a chaotic and unpredictable factor, which leads to the collapse of classical narrative structures. This approach allows us to explore how our perception of time and reality changes in a rapidly changing world. 2. Fictional time in fantasy worlds. In the genre of fantasy, science fiction, time can be reworked to the point of impossibility. In the works of J.R.R. Tolkien or G.R.R. Martin, time in worlds where magic and supernatural forces exist, can flow differently. Some characters can live for centuries, others age quickly, or are in a state of suspended time. Time becomes flexible and manipulated, which allows writers to create new worlds and new possibilities for heroes. Conclusion: time as an invisible hero of literature. Time in literature is a powerful and universal element that not only determines the chronological sequence of events, but also affects the depth of characters, symbolism, and the general atmosphere of the work. It can be linear, cyclical, or completely chaotic, depending on the author's intentions. Time in literature helps us delve into human existence, to make us feel the transience of life, the struggle with the inevitable, as well as the opportunities that time provides for change, growth, and knowledge. Time in art: how artists work with time. Time as an artistic resource. In art, time is not only a backdrop for events, but also one of the key elements that determines the perception of a work. Artists, whether painting, sculpture, photography, or video art, actively experiment with time. They can stop it, speed it up, slow it down, or even use it in the form of cycles and repetitions to create new meanings and emotions. This section examines how time can be used as an artistic tool to not only capture a fleeting moment, but also to explore deeper aspects of human existence through visual images and conceptual ideas. 1. Time in painting: delaying the moment. 1. The role of time in classical painting. In classical painting, time was often perceived as part of an invisible process, depicted through certain moments or moments. Typically, artists captured specific events from history or religious subjects, trying to convey the internal perception of these moments, rather than simply their external reality. One of the most famous examples is Leonardo da Vinci's The Last Supper, where the artist captured a specific moment in time, filling it with deep emotional content. 2. Impressionism: time is changeability. Impressionists' impressions were aimed at capturing not the moment itself, but the impressions of it, including the changeability of light and time. Paintings such as Claude Monet's Impression Sunrise reflect not only a single instant, but also the fluidity of time, which changes colors and atmosphere. This is an approach where time is not depicted linearly, but as a dynamic, evolving process, constantly changing objects around it. Impressionists created effects of flowing time, reflecting brief moments in nature and the surrounding world, thereby expanding the concept of time in art. 2. Time and repetition: cycles that tell the story of human existence. 1. Repetition as an artistic technique: one of the main ways to manipulate time in art is through repetition. In painting, photography, and contemporary art, repetition can become not just a technical device, but also a way to express the cyclical nature of time. For example, the artist RELATIVITY uses the repetition of images and forms to explore the concept of time as a cyclical process. The famous artist Andreas Gursky often uses repetitive elements in his large-scale photographs, such as repetitive architectural elements or mass phenomena, as in the works 99 Cent or Paris, Montparnasse. In such works, repetition not only emphasizes rhythm, but also helps to create a sense of the continuous movement of time and the changes taking place in the world. 2. Cycles and the art of visual time. Time cycles can also be found in conceptual art, where artists work with the idea of repetition through movements, stages of development, or physical changes in objects. The works of artists such as Nikola or John Malkovich emphasize the idea of repetition and cyclicality, where time is not linear, but continuously moves within a certain circle or rhythm. Such works encourage the viewer to reflect on the relationship between beginning and end, life and death, past and future. 3. Contemporary time in video and performance art. 1. Video art: instantaneous time in a contemporary context. Video art has become one of the main ways of manipulating time in 21st century art. Artists such as Bill Viola use video to create works where time is perceived not simply as a sequence of events, but as an experience, where moments become eternal or frozen. In video art, time can be real, slowed down, or sped up. Weiler's work The Passing depicts life as the flow of time through static scenes that change under the influence of time. This creates a deep sense of transcendence and a process in which a person constantly interacts with their own existence. 2. Performance art, time and movement. In performance art, time is used as an integral part of the process itself. Performances are often live works, where artists interact with time directly through their actions, movements, voice, or use of space. Artists such as Marina Abramovic actively explore the boundaries of time, often surprising the viewer with experiments where time itself becomes the material for creativity. Performances can be static or dynamic, but in all of them time is a critical element. It is through time that an emotional connection with the viewer is formed. 4. Time as a symbol in art. 1. Symbolism of time in sculpture. In sculpture, time can be represented not only through movement or change, but also through images that convey the idea of process or cyclicity. Sculptors like Rodin often used complex compositions to represent time in figures that seem frozen in a certain moment. One example, Rodin's The Kiss, where the figures appear to be both static and dynamic, reflecting the immediacy, but also emphasizing the sense of time's infinity in their interaction. 2. Time and destruction. In contemporary art, sculpture and installation also use the theme of destruction as a metaphor for time. Artists like Christopher Walker work with how time changes objects. Destruction, damage or degradation of the material become not only processes, but also a reflection of time itself. Conclusion: time as a work of art. Time in art is not just an element that defines a moment or a period. It becomes an invisible but important hero in the creative process. Artists use time as a resource, manipulating it in order to give the viewer a new understanding of the process that is happening around us. Time in art can be felt, experienced, but it is impossible to define precisely, because it is an integral part of life, which, in turn, is a constant change. Time in science: how physics and astronomy shape our understanding of time. The scientific understanding of time. Time is not just a philosophical or artistic concept, but also one of the main categories of science. However, while in everyday life, we often perceive time as linear and unchanging, in science, it is a more complex and multifaceted concept. Physics and astronomy encounter time in contexts that contradict our intuitive understanding. What is time for science? How can we measure it? And what do the laws of physics tell us about it? This chapter delves into how physics and astronomy influence our understanding of time, from classical theories to modern discoveries in the field of theoretical physics. 1. Time in classical mechanics: Newton's concept of time. 1. Absolute time. Isaac Newton, in his classical mechanics, introduces the concept of absolute time, which is universal for all observers, regardless of where they are or how they move. According to his theory, time is independent of events in the universe and flows uniformly and continuously, regardless of what is happening in the environment. Newton defined time as the fundamental basis that is necessary to describe the motion of objects. In his views, time was absolute and independent of the observer. It was a linear and changing quantity that underlies mechanical processes. 2. Time in the context of Newtonian mechanics: Newton also assumed that time is necessary to measure the motion of bodies. This allowed him to build equations of motion for planets, bodies on Earth, and other celestial objects. Newtonian mechanics became the basis for many scientific achievements and research in astronomy and physics, leaving time as the main unit of measurement. In it, time was absolute and the same for everyone, without any influences on it. However, with the development of physics and astronomy, new concepts appeared that question this perception. 2. Theory of relativity, time and space in a new light. 1. Special theory of relativity. In 1905, Albert Einstein proposed a special theory of relativity, in which time and space cease to be absolute. According to this theory, time is relative, and its fluidity depends on the speed of movement of an object relative to another object. This means that the faster an object moves, the slower time passes for it compared to objects at rest. Space and time are interconnected, and together they form a four-dimensional structure, which is known as spacetime. Time and space can be deformed under the influence of speed, gravity, and other factors. 2. Time is part of the spacetime continuum. One of the most revolutionary aspects of the special theory of relativity is the concept of the spacetime continuum, where time and space are not separate, but are intertwined. This continuum describes space and time as a single quantity that responds to gravitational and other physical phenomena. According to Einstein's theory, for an observer moving at a speed close to the speed of light, time will move much more slowly than for an observer at rest. This phenomenon is called time dilation and has important implications for astrophysics and cosmology. 3. General relativity, gravity, and time warp. 1. Gravity as time warp. In 1915, Einstein proposed a general theory of relativity, in which time and space are not only interconnected, but also warped by gravity. This means that objects with mass can bend space and time around them, causing changes in how time and space are perceived at different points around them. For example, near very massive objects, such as black holes or neutron stars, time can slow down. This well-known phenomenon is called gravitational time dilation. For example, time near the surface of a black hole runs much slower than in remote regions of the universe. 2. Measuring gravitational time dilation. Modern experiments, in particular using atomic clocks, allow us to measure the dilation of time in strong gravitational fields. Using satellites high above the Earth, scientists can accurately compare time on the Earth's surface with time in orbit. The difference in time confirms Einstein's theory of gravitational time dilation. 4. Time in quantum mechanics, paradoxes, and interpretations. 1. Time in quantum mechanics. In quantum mechanics, time is not the same as in classical mechanics. Here, time is not a variable that can be measured exactly, and it is strongly influenced by probabilistic factors. One of the greatest paradoxes is the interaction of spacetime and quantum particles, where different interpretations of time can be applied depending on which quantum theory is used. 2. Time as a parameter in quantum equations. In everything related to quantum mechanics, time is usually a parameter, not a variable. However, some interpretations of quantum mechanics suggest that time can be warped through quantum fluctuations or quantum effects, providing new possibilities for understanding time in context. Microcosm. 5. Time in astronomy, time in space and its measurement. 1. Astronomical time. Astronomers measure time in various contexts, including for observing celestial bodies. For example, a year, a month, a day are the basic astronomical units of time. Based on the Earth's motion around the Sun and its rotation around its axis, astronomical time is also determined through observations of stars and other celestial bodies, which are used to measure mean solar time or atomic time. However, this concept of time changes depending on whether gravitational and velocity effects are taken into account. Conclusion: time as a scientific phenomenon. Study of time in science reveals it as a complex and multifaceted phenomenon. From Newton's classical concept to Einstein's theories and quantum effects, we have seen that time is not as we are used to perceiving it in everyday life. It is not simply a linear quantity, but a dynamic and changing process subject to complex physical and cosmological laws. Philosophy of time. Reflections on the nature of time and its influence on our being. Philosophy of time is a reflection of human existence. Time is not only a physical quantity, that is measured using clocks or calendars. It is a concept that evokes deep philosophical reflections, since it is closely related to our understanding of life, existence, and being itself. How do we perceive time? Does it really exist, or is it only in our minds? How does time affect our understanding of the past, present, and future? Philosophers have tried to answer these questions for centuries, considering time as a key element. In the search for the meaning of life, they reflected on its nature, meaning, and influence on various aspects of human experience. 1. Time as a subjective experience, a philosophical perspective. 1. Time in the philosophy of ancient Greece. Ancient Greek philosophers such as Plato and Aristotle were concerned with the issue of time in antiquity. Plato considered time to be the personification of eternity, moving in a cyclical motion, and it expressed the infinity and ideality of the universe. For him, time was only a reflection of eternal reality. Aristotle interpreted time as a measurement of changes occurring in space. For him, time is not reality itself, but only a way of measuring changes. For him, time was closely connected with movement and changes in the world. 2. Augustine and the problem of subjective time. St. Augustine, a Christian philosopher and theologian, considered time to be one of the most mysterious categories. He asked the question, "What is time?" and answered that time exists only in our minds. According to him, we can imagine the past only as memories, the future as expectations, and the present as a constantly passing moment. All these forms of time exist only in our consciousness, and time itself has no independent existence. This observation became the basis for many philosophical discussions that continue to this day. Is time a real category, or is it just a construction of our consciousness? 2. Time and motion. Observation at the level of being. 1. Martin Heidegger and the philosophy of being. The German philosopher Martin Heidegger considered time only as a physical phenomenon, but also as a component of our existence. For him, time was an integral part of how we experience our being. Heidegger wrote about being until death as a key stage in our reflection on time. Every moment of our lives is permeated with the awareness that time is limited, and therefore, our actions acquire meaning only in the context of this limitation. Heidegger believed that only the awareness of the finitude of time allows us to truly understand our essence and make meaningful choices. 2. Time and motion in modern philosophy. In the 20th century, philosophers such as Jean-Paul Sartre continued to view time through the lens of human freedom and existence. Sartre emphasized that time is not something determined by external circumstances. He linked time to the act of freedom, where the future opens up as an infinite space of possibilities for action. This understanding of time is directly related to our experience of freedom. We are able to give meaning to our time, changing it, choosing how to act within the limits of our freedom. 3. Time and ethics. Moral measurements of time. 1. Time as a resource. In the modern world, time is often seen as a limited resource that must be used efficiently. This issue has become important within the framework of ethics, especially in the context of work, well-being, and relationships in society. We are constantly looking for ways to optimize the use of time, reduce costs, and increase efficiency. This raises moral questions. Is the concept of time economy correct, which puts the result and productivity first? How does this affect our attitude towards our own time and the time of other people? 2. Time in the context of social ethics. An important aspect of time ethics is the question of justice. How should time be distributed between different social groups? How does access to time affect inequality in society? Is it fair to give up part of our time for work or personal achievements, leaving others without this resource? These questions become especially relevant in the context of globalization, where time and the pace of life often become sources of tension and conflict in societies. 4. Time and Change. A look at history and progress. 1. Time in the context of history. Time is also an important element in philosophical reflections on history and progress. Historians, sociologists, and philosophers argue that time is not only a context for events, but also a driving force that shapes the course of civilizational development. In this context, the question that arises is progress linear at all? Is it possible to see a cyclical nature in history, where some events are repeated, while others change only partially? How does time affect the course of events and our understanding of these events? 2. Time and progress in philosophy. Discovering the future. In many modern philosophical directions, time is an important aspect for determining progress. Various thinkers ask themselves, is humanity moving towards a better future, or are we not really taking steps forward, but only approaching new forms of crisis? Is human civilization capable of changing the course of time within its opportunities? 5. Time in culture and art. 1. Time in literature and art. Time has become a central theme in many literary and artistic works. Famous writers such as James Joyce, Marcel Proust, and Virginia Woolf immerse themselves in deep philosophical reflections on how time is experienced by the individual and how it is reflected in art. In this context, the art of time is often perceived as an attempt to capture the passing moment or to create a sense of eternity through temporary forms. Conclusion: time is a philosophical and practical issue. Time is not only a measurable quantity, but also a concept that reveals complex aspects of our existence. From classical philosophical reflections to modern views on society and progress, time is a fundamental element in determining how we live, what we strive for, and how we perceive our existence. Understanding time allows us to shape our vision of the world, change our attitude towards it, and seek new paths in our development. Time in the future. Time travel possibilities and theories of time travel. The idea of time travel has been a prominent theme in human culture and science fiction. From classic works of literature, such as H.G. Wells' The Time Machine, to modern films and TV series, such as Back to the Future or Doctor Who, people have imagined what it would be like to be able to travel through time, to travel to the past, to change the future, or even to see alternate realities. Theories of time travel cover a wide range of possible scientific, philosophical, and ethical questions. How is time travel possible? Is it just a fantasy, or is there a real scientific basis for the concept? In this section, we will explore theoretical approaches to time travel, focusing on the physical and philosophical aspects of the idea. 1. Time travel theories. The role of physics. 1. Einstein's theory of relativity. Albert Einstein, with his theories of special and general relativity, changed our understanding of space and time. One of the key results of the theory is that time is not absolute and unchanging, but depends on the speed of movement and the gravitational field. As part of the special theory of relativity, Einstein showed that time can slow down for objects moving at speeds close to the speed of light. This means that travel into the future is theoretically possible. If you travel very fast, then time will pass more slowly for you than for those who remained on Earth. So, returning after long journeys in a ship approaching the speed of light, you could see the future that has changed significantly compared to how it looked when you set out. But what about travel into the past? Is it possible to go back in time? 2. Spacetime loops and the causality paradox. For time travel, scientists often refer to so-called spacetime loops. These are phenomena that can theoretically occur within the framework of general relativity. If there is a sufficiently strongly curved spacetime, for example, near a black hole or in free space, it is possible that spacetime can be curved to such an extent that it creates a loop that allows you to travel back in time. However, one of the main problems with time travel is paradoxes, such as the grandfather paradox or causality paradox. This is the issue that arises when, by traveling back in time, you change the events that affect your initial state, and possibly create a logical inconsistency. 2. Time-like structures. Are stable paths possible? 1. Curves that return to the beginning. Within the framework of general relativity, there are ideas about so-called returning curves, which could potentially become paths for traveling back in time. One possible model for such travel is the concept of red wormholes, which can be seen as bridges through time and space. These moles or exits through the bends in spacetime could theoretically allow travel into the past or future without violating the fundamental laws of physics. But even in this case, many uncertainties remain about the stability of such formations. Can wormholes remain stable and not collapse during the journey? 2. The role of quantum mechanics. Quantum mechanics adds another complexity to the question of time travel. Using quantum effects, such as vacuum fluctuations and the uncertainty principle, phenomena that distort time and space, creating possibilities for time travel, are theoretically possible. Quantum mechanics can also help resolve some paradoxes, as it allows for multiverse realities, where multiple parallel versions of events exist at each point in time. 3. Philosophical and ethical implications of time travel. 1. Possible consequences of changing the past. If we are able to change events in the past, what consequences could this have for the future? This question is a serious ethical challenge. It is possible to imagine that by changing one event in the past, we create a butterfly effect, leading to unpredictable results in the future. This can destroy the lives of many people or even change the entire course of history. The ethical dilemma is whether we have the right to change the past, and whether this is fair to the people and events that have occurred. 2. Should we travel in time? There is also the question, should we be able to travel in time? Since the changes we can make can affect the entire civilization, the question of responsibility may arise. What happens if we misuse such technology? What limitations should be placed on the possibility of manipulating time? 4. Time travel in popular culture. 1. Time travel movies and books. Time travel is one of the most popular themes in literature and cinema. Classic works such as The Time Machine by H.G. Wells introduce the concept of time travel as an integral part of fantasy narratives. The idea of being able to travel backward or forward in time became a central theme in films such as Back in Time Future, Terminator, Interstellar, and the series Doctor Who. In these works, time travel is used to illuminate important questions about choice, destiny, and influence on the world. They consider not only the physical aspects of time travel, but also the ethical, moral, and philosophical implications of such travel. 2. Time travel as a metaphor. Time travel has become a powerful metaphor for exploring human aspirations, regret, loss, and the desire to change the past. It is often used to explore the theme of change and the consequences of our decisions. This allows us to think about how small changes can lead to big changes in our lives. Conclusion: time as an infinite possibility. The idea of time travel opens up a lot of possibilities for research, both in physics and philosophy. Although we have not yet scientifically found a way to make such travel possible, thinking about it allows us to better understand the nature of time, our ideas about the past and the future, and the consequences of our decisions. Time travel remains not only a fascinating scientific topic, but also an important tool for reflecting on ethics, freedom, and our responsibility for the future. Time and technology. How science can change our perception of time. Time in the world of technology. Every year, science and technology create new opportunities to change our perception of time. Technology has long changed the way we measure and experience time. Thanks to digital devices, rapid communications, and globalization, we have come to live in a world where time seems to be accelerated and interconnected on a global scale. In this section, we will consider how modern technology can change our understanding of time, how it affects our daily lives, and whether there are future innovations that will allow us to view time in a new way. 1. Time in the digital age. measurement, and acceleration. 1. Digital devices and the perception of time. Technology has significantly changed our sense of time. Smartphones, computers, and other digital devices have become an integral part of our lives, and with their help we constantly synchronize our actions with other people. Thanks to the internet, time has become a global synchronized unit. We can send messages, conduct video conferences, and receive information from anywhere in the world in real time. This accelerated interaction with time has become part of our culture. We have become less patient with delays and more focused on immediate results. Science and technology have thus contributed to the emergence of a new dimension of time, where every moment matters and requires attention. 2. Acceleration of time. In digital reality, one aspect that has changed our perception of time is the feeling of acceleration. The huge flow of information that we receive every day through news, social networks, and other platforms can create the impression that time is passing quickly. People have begun to live in a constant flow of information that feels like day after day, or even faster. Technology is also accelerating processes in all areas, from work to personal life. We get instant answers to questions, tasks are completed faster, and even in everyday life we have access to a multitude of automated systems that significantly reduce the time previously spent on everyday activities. 2. Technology and the change in the perception of time. Virtual reality and augmented reality. 1. Virtual reality VR are a time in another dimension. Virtual reality VR, the technology that allows you to create an artificially simulated world in which time can be perceived differently. In VR, users can feel that they are in a completely different time and space. The ability to immerse yourself in other worlds not only creates the illusion of altered time, but also allows you to experiment with how time is perceived on different levels. For people using VR for learning or work, it can change the way they experience time. They can work or learn new skills without being bound by the usual time constraints. VR allows us to immerse ourselves in other eras or even alternate realities, which changes our sense of the present. 2. Augmented reality AR. Time that blends with the real world. Augmented reality AR is a technology that overlays digital elements on the real world, creating a new reality where time and space blend. It allows us to see how new objects or information interact with the real world, creating new measurements of time. With the use of AR in entertainment, education, and business applications, we can see how time can be changed or perceived through the lens of digital augmentations. For example, a virtual assistant or historical elements can appear in the real world, appearing as if they were in the past or the future. 3. Time in the context of globalization. From local to global. 1. The transformation of time into a global dimension. With the ever-increasing globalization, we have witnessed the transformation of time into a global dimension. Thanks to communication technologies, time is no longer limited to local time zones. People all over the world can work, communicate, and interact simultaneously. Problems with correspondence or coordination of activities between different time zones have become more apparent because time is now synchronized at a global level. This also means that technology allows us to work and communicate with any corner of the world at any time of the day. At the same time, this can create tension due to the constant need to be online, always available, and the impression that time passes faster than before. 4. The future of time. How technology will change our perception. 1. Quantum technologies and new measurements of time. One of the most exciting prospects in science is the possibility of using quantum technologies to measure time more accurately. Quantum clocks already allow for unprecedented precision in time measurement. In the future, with the development of quantum computers, we may have access to new ways to measure time and perhaps even manipulate it. Quantum mechanics offers ideas for future technologies that could change our perception of time. For example, using quantum fluctuations to create new ways to control time and its flow. 2. Existing technologies. Impact on the future. Technologies that seem like science fiction today may become reality in the future. For example, brain-computer interfaces, bioengineering, and other innovations may affect how we perceive and experience time. Technologies for creating artificial intelligence and intelligent machines may lead to the fact that the sense of time will change at the level of consciousness itself. Conclusion: time in the future. New horizons. Technologies are changing our perception of time in various aspects, from the speed of information processing to the creation of new realities through virtual and augmented reality. Further advances in science may lead to radical changes in how we understand time, and even to changes in the ways in which it is measured and manipulated. Thanks to innovations, we have already entered an era where time is no longer just a linear flow, but can be interpreted as variable and even interconnected with other realities. Time and its relationship with consciousness. How we experience time. Time as an aspect of consciousness. Time is one of the most mysterious and complex topics to study in science and philosophy. It is not only measured by clocks and calendars, but is also deeply integrated into our perception of reality and consciousness. Time is more than just the sum of instants. It permeates our understanding of how we interact with the world around us, how we reason, plan, and act. In this section, we will consider how we experience time in the context of consciousness, what the neurobiological basis is for our perception of time, and how our internal states can change our sense of time. 1. Time and consciousness. Philosophical perspectives. 1. Time in philosophy. Philosophers have tried for millennia to understand what time is and how we perceive it. Plato, for example, saw time as part of the eternal world of ideas, while Aristotle saw time as a measure of change in the world around us. Thus, time becomes for us not only a physical process, but also an element of our perception of reality. The ideas of philosophers such as Augustine, who argued that time is not an existing thing, but only the way in which we experience change, open up to us the understanding that time is not something external to us, but part of how we experience change and events. It does not exist without consciousness, because we measure it through our perceptions. 2. Time and subjective experience. Each person experiences time differently. For some, moments may seem short, while for others, they may seem long. This depends on many factors: emotional state, level of attention, physiological state, and even social context. These sensations can change throughout the day and depending on life situations. For example, when a person is stressed or waiting for an important event, time may seem to drag on. When a person is enjoying a pleasant experience or is in the flow of creativity, time is often perceived as passing quickly. This phenomenon, which is called the temporal paradox in psychology, shows how our consciousness can manipulate our perception of time. 2. Neurobiological aspects of time. How the brain measures time. 1. Neurobiology of time perception. Our brains have specialized mechanisms for measuring time. These mechanisms include neural systems that respond to external stimuli and determine the duration of events. One such mechanism is our ability to estimate duration without measuring the exact time with a clock. For example, neurons in the brain operate in networks that are used to measure time intervals when we perform various tasks, such as listening to music or orienting ourselves in space. Other parts of the brain, such as the basal ganglia, are also actively involved in the process of perceiving and estimating time, particularly when we observe changes in the environment or try to change our behavior. 2. The influence of hormones on the perception of time. In addition to the brain processing signals related to time, an important factor that affects our perception of time is hormones. For example, levels of cortisol, a stress hormone, can significantly distort our sense of time. When cortisol levels are high in the blood, we often feel that time is passing more slowly. At the same time, under the influence of happy hormones, such as dopamine, time can seem to accelerate. Studies show that in people with disorders in the hormonal system, for example, in the case of depression or anxiety, the perception of time can be significantly altered, which can cause the feeling that time is passing too quickly or too slowly. 3. The psychology of time. How our internal states change the perception of time. 1. The effect of emotions on time. Emotions have a huge impact on our perception of time. When we are happy, time seems to speed up, and when we are bored or anxious, time seems to pass very slowly. This is quite common in various situations, such as waiting for important events or waiting for a long time. Psychological studies show that people who are stressed or depressed often experience a slowdown in time. On the contrary, during periods of joy and satisfaction, we feel that time passes very quickly. These effects are an integral part of how we perceive time in everyday life. 2. The influence of cultural aspects on the perception of time. Or perception of time also varies depending on the cultural context. In Western cultures, where precision and speed are usually valued, time is perceived as a resource that needs to be optimized. In other cultures, where peace and relaxation are valued, there may be a less strict attitude towards precision and speed. For example, in Japan, a high level of attention to time and accuracy shapes people's behavior. A good sense of time can help improve work efficiency and interpersonal relationships in some cultures, while in other cultures, such as Latin American countries, people may be less attached to time, which can reduce the stress of measuring it. 4. Experiencing time in different states of consciousness. *1. Time during meditation and sleep. One of the most interesting aspects of the experience of time is how it changes in different states of consciousness. During meditation, people often report that they lose their sense of time, and it seems either to fast or does not exist at all. This is due to changes in neurobiological processes and a decrease in the activity of certain areas of the brain. We also experience time in a completely different way when we sleep. This phenomenon is especially noticeable in the phases of REM sleep, when our dreams can have a very intense sense of time, although in reality, this time can pass very quickly. Conclusion: time as a part of our consciousness. Time is not something external to us. It is deeply integrated into our consciousness, our emotions, and our physiological processes. The way we experience time depends on many factors, from the state of our mind and body to cultural influences and hormonal changes. Studying how time is perceived in different contexts of consciousness opens up new horizons in understanding what it means to live in time and how this experience can vary depending on our internal state. The future of time. What awaits us in a world where time can be changed? Time as a concept of the future. Time, as we know it, is a fundamental element of our reality. But what if we could change it? What if technology, science, and our understanding of the universe allowed us not only to measure time with incredible precision, but also to manipulate it, change its course, or even stop it? In this section, we will look at how future technologies and scientific discoveries could affect our understanding of time and our relationship to it. 1. Future technologies. How science is changing our understanding of time. 1. Advances in the theory of relativity. Of the greatest scientific achievements that changed our understanding of time was Albert Einstein's theory of relativity. It showed that time is not universal and fixed. It depends on the speed of an object and its distance from massive bodies such as planets or stars. In the theory of relativity, time can slow down or speed up depending on the conditions in which an object is located. In the future, with the development of technology, it is possible that new ways of manipulating time will appear at the level of subatomic particles or even at the macroscopic level. For example, if we can develop devices that can manipulate space and time based on the principles of the theory of relativity, This will allow us to create new forms of time travel and change the course of events. 2. Quantum mechanics and time. Quantum mechanics has opened up new horizons in the understanding of time. Quantum particles can exist in many states at the same time, and this raises the question of whether time can also have a quantum nature. Research in quantum theory can lead to new ideas about how time can behave in a quantum world. For example, the theory of quantum superposition makes it possible to imagine that we can possibly be at multiple points in time at the same time. These discoveries could help develop technologies that allow us to change our understanding of time intervals, as well as determine how time can be manipulated through quantum processes. 2. Time manipulation, possibilities and limitations. 1. Time travel, dream or reality. The ability to travel through time is one of the most popular themes in science fiction. But is it possible in the real world? The theory of relativity suggests that travel into the future could be theoretically possible if you travel at speeds close to the speed of light. However, travel into the past raises many theoretical problems, such as paradoxes and changing history. Despite this, scientists are investigating various aspects that could allow the creation of space-time moles, or tunnels that allow time travel. However, for now, this remains a theoretical idea with no practical application. 2. The ability to manipulate the speed of time. There are also theories that suggest that it may be possible to develop technologies that allow the manipulation of the speed of time on a local level. These could be devices that slow down or speed up the passage of time within a limited space. Such an approach could be used to create effects similar to time travel, where people or objects can experience time differently depending on which part of space they are in. Technologies that allow the manipulation of the speed of time could also have practical applications in medicine, science, or even in everyday life, allowing, for example, to slow down the aging process or change the intervals between different events. 3. The morality and ethics of time manipulation. 1. Implications for human civilization. The possibility of manipulating time carries with it huge moral and ethical questions. If we can change the course of time, it could lead to unpredictable consequences. Losing control over time could create paradoxes, alter the course of history, and even lead to the destruction of our existence. Ethical issues also arise in the context of personal decisions. If people were able to travel in time, would it be ethical to intervene in the past or future, changing important events? This could have catastrophic consequences for human civilization if changes at one point in time led to unpredictable changes at another. 2. Time rights. Another important question is who will own the rights to manipulate time. Will the government or private individuals have access to technologies that allow them to change time? How will the use of such technologies be controlled? This question will become especially relevant in the event of the development of such technologies, which will require careful regulation and the development of ethical standards. 4. Time in the culture and society of the future. 1. A society where time is no longer linear. If time becomes more flexible and manageable, it could change our society on many levels. We could see new forms of interaction with time in culture and social processes. People could start to live in a more cyclical or even fragmented time, where the past, present and future are simultaneously accessible. Such a society could change our understanding of time as a resource. Will we worry less about how we spend it? Will we live in a state of heightened awareness, where every moment has equal value? Conclusion: the future that time awaits. Time is not only part of our physical reality, but also a profound part of our experience and understanding of the world. In the future, with the development of science and technology, we may find ourselves faced with the possibility of manipulating time and changing its course. However, with these possibilities come new ethical, moral, and social challenges that require serious consideration. Time, which we today perceive as fixed and unchangeable, may become flexible and changeable. The future of time will undoubtedly become not only the subject of scientific research, but also an important aspect of our cultural and social development.